Well, welcome everyone to the first meeting for 2020, and people will come in as we wander along. What I'm starting fairly promptly is it could be quite a long night tonight if it drags out for too long. I'll try and be as brief as I possibly can. We were going to have possibly some members from the Willarwarren Aboriginal Association in Hastings and the Bunurong Land Council Aboriginal Association, and possibly even the Nambar Jambana Aboriginal Association in Frankston. But I'm not sure if any are here. I don't recognise any new faces who might be, but given the topic tonight on Australian Aboriginal Astronomy, it was quite appropriate to invite them along. I'd like to acknowledge the land, sea and sky under which we meet are of the Bunurong and Boonwurrung peoples, and we pay our respects to their elders past and present. Which I think is the first time that we've ever done that acknowledgement, so maybe a start of things to come. Now, to begin today, you probably would have seen on emails of the Society that one of the brightest stars in the sky, I think it's the 11th brightest star in the sky, Betelgeuse, which is on the constellation of Orion. That top one up there has started to dim again, and this is a potential supernova candidate. The image shown there from the Hubble Space Telescope is such that they can resolve the star because the star itself is so large, and as you can see by the scale shown on here, you can tell that's quite a jump that the star is much larger than the entire Earth's orbit and is heading on for Jupiter's orbit, so it's already much larger than what even our sun will get to at the end of its life. In the case of Betelgeuse, it's high enough mass that it can go supernova, and fortunately it's 700 light years away, so we hopefully don't get anything too lethal in our direction. And the graph on the right there from the American Association of Variable Star Observers sort of shows how its brightness has gone up and down with time, gone up to about magnitude 0, which is certainly very easily visible to eye, down to around about magnitude 1.1, which is a little bit fainter, but certainly you can notice it by eye. So interesting things may come from that in the next 100,000 years.
I saw something recently that in fact that it sounds like some of the outgassing from Betelgeuse actually goes out as far as Neptune's orbit.
Oh wow, okay.
I think that's sort of like just more like solar wind or something, but it's sort of, yeah.
Like an outer atmosphere to
yeah, it's sort of a thin outer layer,
yeah.
That's big.
Massive. Okay, so tonight, are there any new members here tonight? I know there are a couple there. Nerida at the back there is the one to see if you have any questions about Society. She will put up her hand so that you'll know which one she is. Yeah, holding it up at the back there.
I'll pay.
Oh, you paid, okay. And a reminder that memberships are due in January. Otherwise, we send the treasurer around to your place to come and collect them. Now, I'll very quickly go through some of the events that the Society's done since we last met here in November, because there was no December meeting. Then we'll go through the talk by Duane Hamacher, who was originally at Monash University when this talk was recorded at the Royal Society of Victoria in the city, but he's now at the University in Melbourne. Then we'll break for about 10 minutes or so for a tea break, and then following that we'll have Sky Murphy talking, and then followed by Mark Stevens with Sky for the Month. And then, as usual, 3 shorter videos, one all about animals and the space race, so this is all about the dogs and the monkeys and all those sort of things. We answer the question, can you actually stand on liquid mercury? You've all been wondering that. And also what happens to water as it goes down the Plughole, and yet another experiment, but an interesting one. So, recent events of the Society. Just shortly after our last meeting in November, we had a members' barbecue and the usual maintenance of the site here, followed by our committee meeting. The main things talked about was a wrap-up of the concert, that we did last year during Science Week. Remember the collaboration with the Southern Peninsula Concert Band? It turned out that it was cost neutral, so in other words, it didn't run at a loss, didn't run at a profit, so everybody was happy for us and also the concert band, so everyone had a lot of fun on that one. We also talked about the calendar and the final details of the Christmas barbecue, so nothing of great consequence there to the society financial-wise. 6th of December we had a public night with a fair number of people in here, 81. And unfortunately the cloud was starting to come into our night, so that was pretty cloudy. Then a few days later, on 13th of December, we had a private group here from Rosebud. This is Department of Justice employees, came down to have a bit of a picnic and a talk about astronomy. Unfortunately for them it was 100% clouded out, so we couldn't show them much through the telescopes, but they really enjoyed themselves anyway. It was a very small group here. 14th of December we had the Christmas barbecue in this room here for all the members, and that was where we evacuated this room in 39 seconds flat, which was pretty good going considering that no one was expecting it to occur, and we coincided that with taking a group photo at the same time, so we got them out of the room very quickly and lined them up for a photo at the same time. But it's the first time we've evacuated this room, see how quickly it can be done. 3rd of January, which is only a week or so ago, we had only 67 in here from the public, which is unusually low for January. There was obviously cloud and the bushfire smoke. Maybe the bushfire smoke was helping to keep people away, particularly those with lung issues. 4th of January, which is a Saturday, we had a public night on Saturday. We had about the same number there, turned up about 71, again pretty cloudy for that one. The one last week on the 10th of January, we only had 31 present. Normally at this time of the year, we would be filling this room twice over for the third and the fourth one, to the extent that we have to turn people away, but this year things were down very significantly, so something is very different this year. And we have one coming up this Friday. So on the 17th of January, we have our final public night for January, which is here, and we only got 35 booked so far for that, so again it's still relatively low. This Saturday we've got the members barbecue here on site, and the working bee, the maintenance tasks at 4 PM, so all members are please come and help out there. Next Wednesday we have a committee meeting here at the Briars. 7th of February is the next public night, which is the public night for February, and again fairly low numbers at this stage, only 12. Until the next of our meeting on the 19th of February, which is next month, and we will have a speaker for that one. Now, a couple of things to note down the bottom here. This is not before the next meeting, but this is longer term. We have our Telescope Learning Day coming up in just over a month's time in February, and there are going to be 2 Telescope Learning Days this year spread across the year. Up to now we've only ever done one early in the year, so we're going to trial a second one as well. And the Scout and Guide night will be the Friday after that, on the 28th. Now there's a slight error at the moment in the calendar for the Society that shows different dates, about a fortnight different from those ones, and so we'll have to correct those ones, as our bookings have actually been coming in on these other dates today.
Peter, those numbers on the previous slide,
Yep.
public nights, are they the bookings or the actual term?
Over the actual term. Yeah. For example, on the first night we had bookings of around 80, but only about 67 odd actually turned up. So we do occasionally get drop-ins as well. People turn up unannounced, and it just turned out in that case that the number that came in unannounced and unexpected sort of matched those that dropped away for whatever reason, whether it was the smoke or whatever. And then bear in mind, in May we've got the geological expedition down to Point Leo, and on the 20th of June we've got the solstice party, so that's longer term. Right, so tonight's talk, because the universities are still on holidays, the chances of getting a university lecturer down to talk to us are pretty much zero. They're away on holidays. But in this particular case, we've got a video that was recorded at the Royal Society of Victoria up in the top of Latrobe Street in the CBD by Duane Hamacher. He's these days Associate Professor of Cultural Astronomy at the University of Melbourne. And He'll actually be talking for over an hour, so it goes for about an hour 20, hence why I want to keep things moving fairly swiftly. It's about an hour on the talk for Aboriginal astronomy, and then about 20 minutes of questions after that, and that should be quite interesting to see. If at any time you wish to get up and help yourself to a cup of coffee or that, feel free. It is quite warm in here. We haven't turned the air conditioner on, I noticed, but maybe we ought to switch one on, because it is fairly warm in here. Don't feel that you need to sit down and bear it if you need to get out and have a drink of water or stretch your legs or that. No one will be offended in any way. So I'll begin the video now. If you bear with me.
Ladies and gentlemen, a very warm Wominjeka to everyone here for this very special presentation at the Royal Society of Victoria. My name is David Zerman, and I am honoured to be the 71st President of the Royal Society of Victoria, an organisation, as we say there, founded in 1854. And we're an organisation that promotes science in so many different ways. Since then, we've brought the local community of scientists together with leaders and enthusiasts in other professional and social settings to assist the state of Victoria to grow and thrive from a foundation of scientific expertise, discovery, and an evidence-based approach to problem solving in our state. We have invited elders from the Wurundjeri Council to join us tonight, but sadly they can't be with us, and we pass on their apologies. So first, let me acknowledge that we are gathered tonight on the traditional lands of the Kulin Nation. The Society respectfully acknowledges the traditional owners of this site, the Wurundjeri people, and also acknowledges the Boonwurrung people a little further to our south. We pay our respects to their elders past and present, and likewise extend that respect to any Indigenous Australians who have joined us here tonight. Tonight, we are delighted to examine the encoded scientific knowledge of Australian Indigenous cultures with Dr. Duane Hamacher. Duane is an astronomer and a senior research fellow at the Monash University Indigenous Studies Centre. You will have read about him in the material that we have provided, but I'm always interested in finding out a little bit about the person who's going to present. So Duane, could I ask you to come up and join me for a moment? So Duane, when we were speaking, I noticed that your accent was not typically Australian. Would you like to tell everyone where you're from?
It is not typically Australian, and a lot of people seem a little perplexed to hear about Indigenous astronomy from a bloody American guy. I'm from the state of Missouri, or as I always said, the state of misery, the middle of the U.S. Moved here about 12 years ago, actually 12 years ago last week.
Fantastic. Why did you come to Australia?
Oh, come on, I was a kid growing up in the 80s, you know, Crocodile Dundee, right? I'm not joking, that's why I came. Sorry. No, the first time I came was as an undergraduate student back in 2003. Came to Macquarie University for a semester abroad, had the opportunity, and seized it and had the most amazing experience of my life. I absolutely fell in love with Australia. I know it was Sydney, but I fell in love with Australia and I fell in love with Sydney. I did love it, and I moved back 2 years later in 2006, and I've been here ever since then.
When you were at school, did you have an interest in science in the broadest sense? Was that the area you were interested in?
Yeah, we've all known that guy in school, the really nerdy kid, like the one who made fake pocket protectors and wished they wore glasses. Yeah, that was me. I was obsessed with science since I was probably 4 or 5 years old, and I think my teacher said I was either going to be an astronomer or a paleontologist. I couldn't make the decision for a while, but astronomy sort of won out in the end, so I'm quite fascinated with next week's, or the next lecture anyway, would be quite fascinating.
Was there a particular teacher at school who influenced you and enthused you in science at all?
Yes, I did. I had, in high school, we had a teacher come in. Her name was Elizabeth Sanning. and she was our biology and chem teacher. When I was in my school was so small. My graduating class was 30 people, I think. The town I grew up in only had 45 people in the town I was in.
Wow.
I went to the next town that had a bigger, massive population of about 500 people. Anyway, she was our biology and chemistry teacher. We didn't have physics or anything else. That was it. But she was an amazing teacher, and she really made us work. Going in a small rural school, we weren't always pushed to excel academically as we could have been. And initially we thought she was a bit hard, but it turned out she was an amazing teacher, and she really instilled a sense of academic rigor in me that maintained itself the last 20 some odd years now.
Great. Ladies and gentlemen, I'm delighted to invite Duane to address us on Australian Indigenous Astronomy, 65,000 plus years of science. Duane, thank you very much indeed.
Thank you very much. Thank you for that, and thank you for everybody for coming. Really was excited to be able to come and speak to the Royal Society of Victoria and share with you research that I've been doing for the last decade. Obviously, now that you know I'm American, it's not a surprise. I've given quite a few public talks, and a lot of people thought it was kind of interesting. Why is an American interested in this? I think, why wouldn't you be interested in this topic? You're in a continent that is so ancient it boggles the imagination. People have been here for, just before I came in to do my talk, I put that plus at the end, because that's just the latest findings. When I started doing my PhD 10 years ago, it was 45 or 50,000 years. Now it's 65,000 years. And there's other data out there that shows it could be much older than that. That date is constantly getting pushed back. The point being is that 65,000 years is a long, bloody time to be in one place. And we know that Aboriginal cultures are the oldest continuous cultures in the world, which I find quite fascinating. And if you're like me and you're interested in the subject of the crossroads of astronomy and culture, what better place to come than a place that is this ancient?
When I go to communities and I sit with the elders and we just have an open conversation, I usually just ask some very basic questions, what kind of stuff do we have about the moon and the sun or certain stars? And as we have these conversations, the stuff they start telling me, really opens up. They start, telling about the traditions, the songs, the dances, the stories, just about sort of the abstract knowledge as well. But what I find really fascinating is when we're having these discussions, and they don't sit here and say, well, here's the science behind this tradition. They just have a general discussion about it. But in the back of my mind, I'm going, oh my God, there's so much science here, and I'm just sort of ticking all these boxes off in chemistry and physics and meteorology and geology, running down the list. And, we have a conversation about this a little bit later on, but the knowledge is incredibly deep.
My background, just so you know, is in both astrophysics. I did my undergrad and my master's degree in astrophysics, and I did my PhD in Indigenous Studies, which was a real big jump for me to go from the hard sciences to the social sciences like that. It was a pretty substantial challenge and something I'm still navigating my way through. But what I wanted to talk to you about tonight is something, oddly enough, that seems quite contentious, that Aboriginal people had science. Wow, to me that doesn't seem surprising at all, but to a lot of people out there, that is quite a statement. And to imply they had astronomy or science, I'm having some wars with colleagues now about whether or not Aboriginal people had this. So what I want to talk to you about today is the work I've been doing specifically looking at the scientific knowledge, the scientific information encoded in Indigenous traditions. And I actually use Indigenous as a bit of a double entendre. For one, because I'm going to be talking about both Aboriginal and Torres Strait, not just Aboriginal, but also because it's the Indigenous astronomy, it's the pre-Western scientific astronomy. It is still scientific, and that's something I hope everybody I can convince you of before we leave today. Now, before I go on, I think most of the people in the room are probably familiar with this. How many people have seen this map before? Excellent. So I don't need to tell you what it is, but I will anyway. These are all the major language groups in Australia. Each one is unique. They're not all dialects of the same language. As you can see, every one of those colored spots represents tremendous diversity that goes back tens of thousands of years. And also there was connection between these different countries. These were not little autonomous areas that didn't have any interaction with surrounding communities. There are extensive trade networks that go all across the country, north, south, from the Kimberley to New South Wales, from Tasmania to the Torres Strait.
Each of the different languages in Australia is different. There are some that are similar families, there are some that are completely and totally different, the completely different language group altogether. So what we've learned from the communities is, there's a lot of trade, there's a lot of networks that crisscross the country. The idea that Aboriginal communities were somehow isolated in these little spots just isn't true. There was trade all across the country, trade with Indonesians, with Melanesians. And one of the major ways these trade works were put together were through song lines. So basically you're singing the traditions as you go across the landscape, and the songs tell you where the water holes are, they tell you where the shelter is, they tell you where the animals are. But the song lines can stretch from coast to coast, north, south, east, west. And the song lines are in different languages. As you're singing the song, when you get to new country, the language of the song changes. So you can actually navigate your way across the landscape by knowing these song lines.
Has anyone been to the Seven Sisters Songlines exhibition in Canberra at the National Museum of Australia? Has anybody seen that? I think you've got 1 week to go, is it, the end of this month? If you haven't seen that, it's phenomenal. And I'm going to talk a little bit about that later on, one particular example from this area over here. But that songline goes all the way across the country. So what I'm getting at is I'm going to give you a bit of breadth about scientific information encoded in the traditions of a handful of different Aboriginal and Torres Strait Islander communities. But what I mainly want you to understand at the end of this is that there's incredible diversity. I forgot to turn my timer on so I don't go over, because I will just talk forever. And you'll say that's okay now. Give me an hour and a half, you'll be saying something different. One of the things that we also need to recognize and understand is that Aboriginal and Islander cultures in Australia didn't have a structured written language. Was information put to writing? Yes, it was. And we're going to look at some of the ways that was done as we go through. But it wasn't a structured written language. What we had here and have here are oral cultures, and this is pretty much everywhere around the world up until a few thousand years ago. Orality is really a phenomenal concept, and it's one that's critically important to understanding not only the scientific information encoded in oral tradition, but how this knowledge can be passed down for so long without degrading.
The ways that the elders are able to encode so much knowledge and pass it down is something called the method of Loci. And that term itself comes from the ancient Greeks. The ancient Greek orators would use the idea that you could associate a memory with a place. And the place can be anything. It can be an object, it can be the landscape, it can be the skyscape. So when I work with communities, I notice they encode everything into stories, into narratives, into songs, into dances, and it's also encoded in the landscape, and all of that is reflected in the skyscape. So there's multiple layers of memorization, so to speak, where you can take all this knowledge and apply it to anything.
So when we talk about orality, the human brain has evolved to memorize vast quantities of information. We tell stories. I try not to use the word story too much, and I don't like to use the term myth and legend, because myth and legend are very loaded terms. Modern colloquial English, myth is the opposite of fact. So when we talk about, I don't use the term Aboriginal myths, but these are narratives. These are stories where you pass on, you encode information in that story and you pass it on. So if you're going to memorize everything, you don't want to have long, dry lists of boring facts. How many teachers of science do we have in the room? None. Really? There's no science teachers here. There's a couple people like Freddie. Trying to get students to memorize stuff is very difficult. You got to be creative and think of how can you do this. Well, having a very interesting narrative where you tell a story and you've got, supernatural figures coming down from the sky and morphing into animals with superhuman feats of strength. These kinds of things are going to be things you remember. We have an entire movie industry based on that. Books, novels. It doesn't necessarily mean it's dogmatic. It doesn't necessarily mean that you believe this is actually what it was, physically was like this. Because each community's got their own different types of traditions and narratives. But the idea is you can remember information a lot easier if you do that. Song and dance. I mean, I'm walking through Woolies or Coles these days, and I can tell I'm a Gen Xer because all of a sudden, it's one of these songs from the 80s pop up, and I can remember the lyrics of a song I haven't heard of in probably 10 or 15 years. It just pops right back to mind because we've got a pretty amazing ability to memorize or to remember song lyrics. So if you take that knowledge, you encode it in story, you also encode it in song, and then you action it out through dance. And then through social practices, through craftsmanship, through artifacts, you're able to pass on, you take huge amounts of knowledge, encode that into these things, then pass that on through the generations.
We don't have to worry so much about that knowledge degrading over time because there's very strict protocols on how this is done. It's done through ceremony, where there's reward for doing it correctly and punishment for doing it wrong.
One of the activities a lot of teachers will do with primary school students, I'm sure everybody in this room has done it, you line up a bunch of students, teacher at one end has a phrase, they tell this student they're supposed to whisper it to the next person's ear, and by the time it gets to the end, you're supposed to see the same thing. I can't exactly remember what kind of moral lesson you're supposed to get out of this, because inevitably there's a smart-ass kid in the middle who has to say something really rude and disgusting or vulgar, and it never gets to the end of the room. This is often used as an example of why oral traditions don't work. Oral traditions do work. There's evidence of that everywhere. The fact cultures have survived and thrived for as long as they have is evidence that oral traditions work. Now, if instead of having a row of students, you took 4 groups of students, 3 or 4 in a group, you had them memorize a story, and you told them they're going to get a fantastic reward if they can pass that story on, they're going to get a pretty horrific punishment if they can't. I guarantee you, threat of getting speared in the leg, you're going to remember what went down to the other end of the room. That knowledge is going to pass through. And in these cultures, you have multiple generations. You have the grandparents, the parents, and the children, all reinforcing this knowledge with the community that's passed on through ceremony that has very strict protocol and guidelines. You've also got a hierarchy of knowledge, and knowledge restricted by gender, men's business, women's business. I can go on forever talking about this. I'm not, because what you need to do is check out this amazing book by Lynn Kelly. I've worked with her a little bit. She's doing a new book right now on memory. She worked with Aboriginal communities here in Australia, learning about the method of loci, how they use that, and she came up with new frameworks that help explain a lot of famous archaeological sites. So let's move on. What is science? When somebody says science, what comes to mind? Anybody want to throw out something? When I say what is science, what comes to your brain? What comes to your mind? Empiricism, right? What else? Everybody's terrified. It's like my teaching undergraduate classes, you have to pick somebody in the front. Yep. Objectivity, right? It's trying to understand the world around us, right? We try to understand the world around us through observation, through experimentation, through trial by error. We need to know how our world functions. We need to know, can I eat that plant? Can I chase that animal, or is it going to eat me? How am I going to tell if the seasons are changing? How am I going to know what the weather's going to be like tomorrow? How can I survive? And then how can our culture thrive? Those are all aspects of science that we're going to be looking at. And one of the key things about science is that science makes predictions. Now we can look at predictions can mean a few different things, and I'm going to use predictions in a pretty specific context throughout the remainder of my talk. But all the scientific knowledge, all the scientific information that we're going to be exploring has predictive purposes. So really, in a very general sense, science is about trying to understand the world around us through observation, through experimentation, through empiricism. Now, there are so many examples. I sit down and think, what am I going to talk to these people about? Because there's just so much stuff. What I would like to do is focus a little bit more on a few major themes and keep that focus more on topics that I've been publishing papers on fairly recently. So, when we look at the sky, we notice a few things about the stars. We notice the positions of the stars. That's one of the most critical things when I talk about indigenous astronomy, is noting the positions of stars. Where are stars in the sky? They rise in the east, set in the west. But some of the stars towards the north, they rise and set. They're not up in the sky for very long. They don't They don't get very high above the horizon. Stars in the south, they never set. They're always in the sky. So you've got a range of different types of stars, where they rise and where they set, how long they're going to be in the sky. Those can tell you different things. So you want to really pay attention to when do they rise or set at dusk and dawn. That's what most Aboriginal and Torres Strait cultures look at. So when I say the word constellation, what comes to mind?
Group of stars that we see from our perspective, but they might be, endless light years away from each other. It's just how we see.
Excellent. So a group of stars in the sky, we usually kind of trace, connect the dots, and they make a familiar shape, right? So we know of Orion, we know of Scorpius, we know of the Southern Cross. That's the most famous. But not all constellations are composed of the bright stars. In Aboriginal cultures in particular, a lot of the constellations are dark sky constellations, not made up of the stars, but of the dark spaces in the Milky Way. One of the great things about living here in the Southern Hemisphere is you get an amazing view of the Milky Way, an amazing view of the night sky. There's so much more to see from the southern skies than there are from the northern skies. You get the Magellanic Clouds, you get the middle of the galaxy, the galactic bulge. There's so much more to see. And when you look at the Milky Way outside of the light pollution of the major cities, you see beautiful dark spaces in the Milky Way. Astronomers call that absorption nebula, sort of cool gas and dust absorbing the light of background stars, but they make some pretty incredible patterns. So let's look at a couple. The dark spaces in the Milky Way tracing out a beautiful silhouette of an emu. We can see right here's the Southern Cross. These are the two pointer stars. This dark space by the Southern Cross, Western astronomers call a coal sack, very dark blotch right in the Milky Way. But the galaxy itself traces out this beautiful outline of an emu. So this is an example of a dark sky constellation. Now the knowledge contained in what this means is quite deep, and we're going to go into some depth with this. There's all kinds of layers of knowledge, and some communities talk about there being over 30 layers of knowledge. And a lot of what I've learned from this, what my students have learned from this, really are the bottom levels of knowledge. Everything that I've learned here, I've learned from community, from elders. Obviously, this is not my knowledge, but they've been very generous in sharing some of their lower levels. And their lower levels of knowledge are quite detailed.
It's like a pyramid. The base level everybody knows. But as you get higher and higher and higher, fewer and fewer people know some of that really high detailed knowledge. Some is restricted by initiation, some is restricted by gender, whether it's men's business or women's business. There's all kinds of different restrictions and qualifications on who can know that, or who can possess that knowledge, or be curators of that knowledge.
The acronical rising, or opposite the sun. So as the sun goes down, the emu rises in the evening. This starts to happen in March and April, so we're coming up on this now. That signifies the time the emus are laying their eggs, which can be collected as a food source. But the details of knowledge are far deeper than that, so let's go another level of knowledge up. Even though, to most of us, our eyes will see that shape in the sky as being constant. The stars aren't moving around. It's the same shape in the sky. The way the Gamilaroi perceived it, and the Uwalyi people would perceive it, is it would actually change in shape and change in meaning depending on where it was in the sky at sunset throughout the year. And when I talk about this, you're going to see some of the interesting science come out of this. So, right here, frame A, this is early in the year, so when the sun's gone down, the emus come up. This is March and April and May. It's a female emu, and she's running. Does anybody want to hazard a guess at why the female emu is running? What was it? The male emu is after her. Close, it's exactly opposite. She's chasing the males. The females chase the males for a mate. This is the breeding season. This is when they begin laying their eggs. This is why the Gamilaroi talk about this being the time to collect the emu eggs. Of course, a little bit later on, at about June, July, frame B, we see a bit different. You don't see legs in the emu. Now it's a male emu, and he's sitting on the nest. So this is so the females mate with the males, they lay the eggs, and they bugger off. They leave it up to the males to take care of everything else from that point on. So the males sit on the eggs and incubate them. The incubation period is about 58, 59 days, so roughly 2 months. Over that 2-month period, it doesn't really show it very well in the image. It's pretty horizontal across the sky. It starts to tilt a little bit at sunset. This time of the year up here signifies sort of the autumn period. This is pretty much in the depths of winter. As we start to get into the springtime, in frame C here, we see the male emu getting up off of the nest. Why is he getting up? Chicks are hatching. 2 months has gone by. So it is this period in time when the males begin rearing the young. They begin teaching the emu chicks, taking care of them, doing the normal dad stuff for the emus. A little bit later on, when late autumn and early summer start to come in, you notice the emus twisting around in the sky. And this is the next frame over. And it looks a little bit strange because you'd expect actually the head of the emu here, and this is the body. It should be that, just rotated like a clock. But the way it's conceptualized is different. When the emu in the sky is low on the horizon like this at sunset, the image flips around because it actually looks like an emu's bum just above the horizon. During this time, the emus go and they start sitting in the water holes. And as they sit in the water holes, it displaces the water. And the water in the sky falls down as the rains that tend to pick up a bit that time of the year. But as the summer comes on and the emu sits just below the horizon, that means all the emus have left, it's too hot, the water holes have dried up, and their heads will peak above the horizon again in about February. So what you see from this tells you about the behavior of the emu, it tells you about the availability of food sources, and it tells you about seasonal change. And that's just this one little next level up. This is about the 3rd grade version, year 3 version of this story. What's also interesting is how this relates to ceremony. So all these traditions have a scientific component, and they have a social component. The social component here relates to ceremonies. When a lot of the initiation ceremonies occurred, were at this time of the year, right here. And the reason is because the ground, I know it's very difficult to see because this thing is very dark, but this is the Milky Way right here. It connects with the land. It creates a direct pathway between the land and the sky. And a lot of the ceremonial grounds, which usually comprise a large circle and a small circle connected by a pathway, are mirrored in the sky. And one of the things you'll read about with Aboriginal cultures is everything on the land is reflected in the sky. Everything you need to know to survive about how the seasons work, the animals, the plants, the landscape is reflected in the sky. The sky is a textbook. It's a law book. It's a science book.
You can't talk about that star without talking about this plant, this animal, this landscape feature, this season. Everything is linked. And one of the fascinating things about researching astronomy from an Aboriginal or Torres Strait Islander perspective is that as a researcher, as an academic, with my background training in astrophysics and learning about indigenous cultures, I have to learn about ornithology, about herpetology, about insects, about meteorology and geology, all these areas that I don't know that much about. I have to learn about all that. And the breadth of knowledge you need to try to understand that is quite significant.
Colors of stars. What colors do you guys normally see when you look up? Look at the stars. What colors do you notice? Red and blue, white? It's about it, really. The reason for that is mostly about how the human eye functions when you get night vision. You can really only see sort of blue and red. That's about it. So what are the Western stellar classification systems? This is Astrophysics 101. Spectral classes, we look at the spectrum of a star. There's a relationship between its color and its temperature, and that's how astronomers classify it. We have these very red class M stars that are pretty cool. They're about 3,000 degrees in the surface, getting all the way up to these super hot blue class O stars, which get up to 50, 60,000 degrees in the surface. What's interesting is that Aboriginal cultures had a very similar kind of classification system for stellar colors. This is from the Luritja people in the Central Desert. In general, they divided the stars up into 2 main color categories. Tatica Jilkara, which are Jilkara, which are your white stars, and Tatica are your red stars. Those that are a bit yellow are called Tatica Jilkara, combination of the two. And the ones that are very, very red are called Tatica Indora. So very similar to the way astrophysicists do that. Now, if you would take the top 100 stars, the top 100 brightest stars in the sky, and look at them by color, a majority of them are sort of this whitish color, bit of a blue color. You don't see the blue very well at night when your eyes adjust to the dark. It's mostly white. Some of the sort of whiter red ones, but a very tiny percentage are the bright red ones, the really dark red ones. Yet these, and probably for this reason, are some of the most significant. The colors of the stars are often reflected in what they represent, whether it's a plant or an animal. So for example, what color star do you think this cockatoo is related to? A red star, right? And the Kokatha people up near Ulia in South Australia, the red-tailed black cockatoo is linked to two celestial objects, Antares and Mars. Now, what's very interesting about that, and you're going to notice some remarkable similarities between Aboriginal traditions and Greek traditions, is that who was Mars? What does Mars mean? And Mars was the Roman god of war, right? It's bright, it's red. Antares means the opposite of Ares. Who was Ares? Ares was the Greek god of war, right? So like Ares, Antares, Arctic, Antarctic, the opposite of, rival of. These two objects, similar brightness, both very red, both quite bright, both occasionally coming nearby in the sky, fight for dominance. Same you find in many Aboriginal traditions. But the color red is very important, and I'm getting somewhere with this, trust me. Another example. In some of the Burong Regaya traditions of Western Victoria, up near Lake Tyrrell, Sea Lake, as it's otherwise known as, the town up there, the Burong people, some of the earliest records of indigenous astronomy come from the Burong, of the Regaya, their clan of the Regaya language group. Their traditions, there was a man who was chased by a giant man-eating emu called Chingal. Chingal chased him. Chingal was killing people in the community, and he was supposed to go out and kill Chingal. But instead of killing Chingal, Chingal chased him up a yarra tree. We see that yarra tree as the Southern Cross, and the top star of the Southern Cross is Bunya. For his cowardice, the ancestors turned him into a ring-tailed possum. And what's interesting about that is if you look at these stars, white star, white star, white star, red giant. The red color of the star itself is reflected in the color of the animal. Now, why is this interesting? Why is this important? Well, we learned that when stars rise and set, they relate to some aspect of something happening on the ground, whether it's a changing season, the behavior of an animal, even the flowering of plants. But what I found really fascinating is something that wasn't really recognized until about the last couple of years. And that's that Aboriginal people, we know they pay very close attention to the subtlest changes in the environment. What about astronomical phenomena? We know they're very rare and very subtle astronomical phenomena. Did Aboriginal people in the past pay attention to that? Did they notice? Do we have evidence of that? Of course, the answer is yes. This is one area that right now I'm having a bit of a war with another person over, is the variability of stars. What I mean by variability is the changing brightness of stars. Most of the stars in the sky actually do change in brightness over time, but it's so subtle or so slow, there's no way your eyes are going to pick it up. But there are a handful that do change that are noticeable. And if you're paying attention, you can recognize them. I'm going to put this in the context of this beautiful constellation I'm sure a lot of people know all about. Anybody know what constellation this is? It's Orion, right? So there's this red giant star up here called Betelgeuse, as I say, Rigel. You see the three stars of his belt, and this, okay, this is the Royal Society of Victoria. This is commonly called the scabbard of Orion's sword. The scabbard of Orion's sword is a sort of cleaned up Victorian version of what it originally was. It was not a scabbard. If it looks like something else, it's because it is something else. So that actually has relevance. So, of course, this is looking at it from the Northern Hemisphere view. If you come down here to Australia, Orion is upside down. The Greeks saw that as his, What we find with Aboriginal communities is there are a number who also have the same constellation and see it in the same orientation, upside down. Why do we know this is upside down? Two reasons why. Number one, the early ethnographic records said it was upside down. Whether it was Nairuna, Miami, talked about him being upside down. Some of them say this was his tassel. This is the Wiradjuri version of Miami, is a bit more anatomically correct. Why is he upside down? Well, the traditions vary. With the Wiradjuri traditions, Miami was chasing an emu. He was hunting an emu, and he tripped and fell over the horizon. That's why he's upside down. And during some of the ceremonies, you'll see Miami with his arms up, face down on the ground. That exhibition in Canberra about the Seven Sisters, this is part of a song line that goes from the Central Desert all the way to New South Wales. They also show him being upside down. The elders say he's upside down. So what does this mean? What does this have to do with stellar variability? Well, there's a story that was recorded by the famous Irish amateur anthropologist Daisy Bates back in the early 1900s, about 1905 to 1930 something. She was living out in the desert, the Western Desert. And she wrote down some aspects of one of the popular stories out there about Nairuna. Nairuna was a hunter. He was a man, very proud of himself, very attractive guy. Just like the Greek version of Orion, he was very proud and he was a womanizer. And he was not used to women telling him no. He saw these seven sisters of the Pleiades, the Yagharilian sisters, fell in love with them, and made the decision that he wanted them to be his wives. Wanting them to be his wives is a very polite euphemism for saying he wanted to pursue them aggressively whether or not they said yes. So he would chase them across the sky. But their eldest, they were very timid. They tried to hide away. Their eldest sister, Kambugara, knew what Nairuna was all about. And she knew that he could be controlled, just like most men like this. So she would stand before him, that V shape, which in the Western traditions are the horns of Taurus the bull. Those are her legs. And I'll let you guess what she's doing to him. She's taunting him. She's mocking him. She's laughing at him. He gets very upset about this, so he creates fire magic in his right hand. This fire magic builds up. He's going to use his fire magic to cast at the eldest sister to get her out of the way so he can get access to the younger sisters. She counters this by creating fire magic of her own in her left foot, which is the star Aldebaran, another bright red star in the night sky. She kicks sand and dust into his face. This humiliates him, and his fire passion dies down. But being the man that he is, he doesn't take no for an answer, and he gets right back up a short time later, and he starts creating the fire magic again. Well, this time, the eldest sister isn't quite ready for it. So, to get some assistance, she calls out for Baba, the father dingo. Baba comes and aggressively attacks Nairuna, shakes him, while the rest of the stars, including the sister, sit and laugh and mock him. When this happens, his fire magic dies down again, and Baba the father dingo places a row of dingo pups between him and the eldest sister. That row of dingo pups is the shield in the classical version of Orion. So what we find from this story is a description of these two stars, in particular Betelgeuse, getting brighter, because this record says he actually gets brighter and hotter and then fades again. Well, what we know about Betelgeuse is that it's a variable star, and it's quite noticeably variable. So for those who are having a small heart attack, seeing some graph on the board, all this does is plot out the brightness of a star over time. If the brightness of the star didn't change, it would be a straight line. It's obviously not a straight line. Betelgeuse is a red giant star, semi-variable. It doesn't have a regular period in its variabilities. It's a bit sort of zigzaggy. But the difference between its brightest and its faintest is over a magnitude. It's very, very noticeable to the eye, with a period of roughly about 400 days. So if you're observing the sky every 400 days, and you're paying close attention to Betelgeuse, especially in a place where you've got good, what astronomers call seeing conditions. Pretty still skies, not a lot of humidity, stars are high in the atmosphere, you get a very good look at them, you're going to notice the variability of Betelgeuse, and that's exactly what the people did. What's interesting is the star Aldebaran is also variable. Much different. Its variability is very small. It's noticeable, but it's very small. But it doesn't vary as much in the same time scale as Betelgeuse, which might explain why she wasn't prepared when his fire magic came back and she had to call on the Father Dingo to help. So we have evidence of the variability of the stars from over a year recorded in Aboriginal traditions. We also have the variability of the star Antares recorded, and its variability is up to 4.5 years to 5 years. Something else quite fascinating about the stars is something we all notice about them. They twinkle. We've all seen the twinkling stars. We've got lullabies about it. We've got poetry about it. But what is it about the twinkling of stars? What causes stars to twinkle? Does anybody know? The atmosphere, exactly right. Turbulence in our atmosphere is what causes them to twinkle. Now, as a science student, I knew this, but when I was sitting up in the islands with the elders, I'd heard something about the twinkling of stars meaning something. So I asked one of the elders, can you talk to me a bit and tell me about what the twinkling of stars mean? And I had multiple elders going into all kinds of detail about how you read the twinkling of stars. Not just that they twinkle, but how you read it.
So they sat with me and they say, well, we look at how the stars twinkle. We know how to read the stars. It's one of the phrases they use quite often in the Torres Strait and with Aboriginal people, how to read the stars. And they'll say you look at the bright stars that are high above because they're the best ones to look at. You look at the bright ones. You look at how they twinkle. Are they twinkling really rapidly? Are they twinkling slowly? Are they kind of sharp or are they kind of fuzzy? What colors are they? I'm like, this is neat. What does that tell you? And they start explaining to me how they use this to predict weather, how they use this to predict seasonal change, trade winds. When the stars appear very blue and a bit fuzzy, they know they need to begin planting crops right now. They know they're not going to go out on the reef that night to go hunting for dugong or turtle, for example, because the rain's coming.
So what I'm going to do is play a real quick song for you. And I'm going to translate the song because this is in the Merriam-Webster language. I want you to listen for the science encoded in this. Why is it so calm tonight? Why are the stars twinkling so brightly? Like embers in a fire. It's a sign of the changing big wind. That moves rain clouds, a very specific kind of rain cloud, from the south up to the northwest. Why are the stars twinkling so brightly? So what Uncle Allo is talking about there is how you read the stars later in the year. This usually happens around November, December, early December. You pay attention. At that time of the year, you get the doldrum, very still on the ground, very hot, but very still, very fine weather. It says you look up, you notice the stars start twinkling really rapidly. They're really flashing. But you have to look at the bright stars. You have to look at the ones that are high above, not just any stars. The ones that are bright and high above. If you see them twinkling very rapidly, you know the trade winds are shifting. So up in the tropics, you've got the cooler, drier southeasterlies and the hot, humid northwesterlies. The northwesterlies bring the monsoon rains. So what you see at that time of the year, when the stars are twinkling, is a shifting of the trade winds. And they know how to read that and know when the next season is going to come. You find this in some of the Aboriginal cultures as well. The second brightest star in the sky, Canopus, signals the coming wet season in Wardaman traditions because it's flashing very brightly in the sky.
As we're sitting with the elders, I'm recognizing all the science encoded in these stories and this knowledge, and I just find that I find it fascinating, but not surprising at all. We would expect people over 65,000 years to figure this stuff out, of course.
But something else he taught me I thought was pretty fascinating. He says, look up at the stars at night, and not just seasonal change, but you want to learn something about weather. Look at the bright stars. Do they appear very blue? If they appear very blue and kind of fuzzy, then the farmers know they need to begin planting now, and you probably wouldn't want to go fishing on the reefs or hunting on the reefs because it's going to rain soon. When he told me that, I'm sitting here thinking, where's this coming from? What does that mean? How the twinkling? Oh, wait a minute. Hang on. We don't see blue very well at night because our eyes can't adjust to it very well, but there are occasions when it can be very blue. What would make the stars appear very blue and twinkling? Twinkling, we know, is caused by the turbulence in the atmosphere. The stars would look fuzzy if there's a lot of humidity in the atmosphere. Well, what does water do? Water absorbs red and green wavelengths of light. So this is a coefficient. This is how much absorption you have versus the wavelength. So you see it starts to absorb a lot of the red, absorbs some of the green. When you get down here to the blue end of the spectrum, it doesn't absorb very much of that at all. So all that incoming starlight, most of that red and mostly green light gets absorbed by the humidity in the atmosphere, and what comes to you is very blue light. Oh, wow, okay, so Uncle's sitting there telling me the physics of how this works, which is pretty fascinating. So just knowing how to read the way the stars twinkle can tell you about seasonal change and can tell you about weather. Well, moving on, what about the dynamics of the moon and the sun? We're all familiar with lunar phases, and we all know that moon phases link to tides. You get the highest tides here at the full moon and down at the new moon. The reason for that is because the Earth, the moon, and the sun are in a straight line, and their combined gravity causes the greatest bulge, and that causes the higher tides. When you get the quarter moons, like this here and this down here, that means they're at 90-degree angles, and you still get the tides, but they're lower. Well, this is a great way to figure out when, for example, to go fishing. So on the Torres Strait, every time I would go on a fishing expedition, it was always at a quarter moon. I asked one of the uncles, why is it always a quarter moon? He says, oh, this is the best time to go fishing. Okay, why? Well, you can see the fish easier. Why? Oh, God, bloody academics asking so many questions. All right, so when you have the lower tides, when you have the higher tides, like at a full moon and a new moon, the tides come up, the tides go down. Tides come up, tides go down. What do? They churn the water up. When you have these low neap tides, they're not churning the water up so much. The water's much clearer. So you have a better chance of catching fish if you do it at a quarter moon than if you do it at a full moon. How many people have seen one of these? It's a big ring around the moon. Who's seen a ring around the moon like that, right? What usually happens not too long after you see your ring around the moon? It starts to rain, right? Why? Well, moon halos predict bad weather because halos are formed by ice crystals high in the atmosphere. I won't go into the physics too much, but light comes in, sort of gets refracted off the inside, bounces out the inside of the ice crystal, and causes these 22-degree halos. It means they're 22 degrees across, about the width of your hand like this at arm's length, about that. You can get a 44-degree halo, you can get arcs, all kinds of things. But the ice crystals form in the atmosphere during low fronts. What do low fronts bring? Meteorologically speaking, they bring rain. But not just that they bring rain, but can you count stars inside the halo? If you can count several stars inside the halo, it's probably not going to rain for several days, if at all. But if the halo is really fuzzy like this one is, rain is pretty imminent. Why? Same thing I was talking about before. If there's a lot of humidity in the atmosphere, that's going to be like a fuzziness, a haziness. It's going to fog out the stars. So knowing how to read halos helps. Who has seen an eclipse? We had one up in Cairns about 6 years ago now, right? Raise your hand high if you saw an eclipse. I saw it. It's one of the coolest things I ever saw. I only got to see the last 15 seconds of it because bloody clouds came right in the way. I got in the car and drove down in front of a solar panel shop in Cairns, and I got to see the last 15 seconds of it. Solar eclipses are extremely rare events. They only occur from any given location in the southern hemisphere about once every 300 or 400 years, give or take. but they are quite common in Aboriginal traditions. Very rare events, few hundred years. Think of how many generations go between seeing successive solar eclipses. But they're talked about quite extensively. And how do the Aboriginal people talk about them? There are a few different descriptions, but most of them talk about it being a superposition of the sun and the moon. In most cases, the moon is a man and the sun is a woman. Guess what they're doing right here? Wink, wink. They're embracing. So incredibly rare events describing the relative position of the sun and the moon. And knowing it's the moon makes a big difference because this happens during the new moon phase when you can't see the moon. The moon is near the sun in the sky. We're looking at the back of it. So Aboriginal people knew very well where the position of the sun or the moon was relative to the sun throughout the year, throughout a lunar month. They also knew very carefully about the analemma. If you take a photograph of the sun every day at about the same time, it makes this weird sort of figure eight pattern. And the reason it's kind of a lopsided figure eight and not a symmetrical figure eight is because the Earth does not go around the sun in a perfect circle, it goes around an ellipse. So as we come around a bit to the sun, coming closer to it, we go faster, and when we're further away, we go a little bit slower. Point being, you see the sun setting at a different point along the horizon every day. How many people saw Melbhenge recently? Saw Melbourne Henge? You guys heard of Melbourne Henge? Melbhenge? A few hands up in the air. We all know that the grid of the city is sort of cockeyed a bit. There's 2 days of the year that the sun is going to either rise in the east or set in the west, and it's going to be directly down the avenues of the roads. So you sit up at Parliament House and you look down, the sun kind of goes behind the buildings, and it pops out right as it sets, and the disk of the sun is right there between the buildings going down the street. It's an amazing sight. Aboriginal and Torres Strait Islander people knew of this very well. How are you going to notice the variability of stars changing and solar eclipses, but not notice the sun moving at a different point along the horizon throughout a year? Of course they're going to notice that. The Torres Strait Islanders, this is the island of Moa, the village of Kuban here, would actually look, there's lots of little islands all over the place out here. And just in December, just a couple of months ago, one of the elders and artists was telling me that what the people do is look at where the sun sets between the islands or over the islands. So there's one particular island right here. It's got a peak there and a peak there. There's a bit of a flat part in the middle. When you look and see the sun setting on the flat part, then you know that it's a solstice. When it's down here, it sets between, just right at the very edge of this island, you know it's the summer solstice and that the monsoon wet season is going to be pretty much imminent. This happens on the 21st of December. Wet season starts at the end of December. Ties in very nicely. Then, of course, you have stone structures. How many people have heard about Melbourne Stonehenge? A few people, right? I've been to this site about 47 gazillion times now. This is called Wurdi Yuang. This is just out at the Yuyangs, just the north edge of the Yuyangs between here and Geelong. It's a series of stones about knee to waist height that make a large egg shape. It's about 50 meters from here to here, and it lies exactly on an east-west axis. And these straight edges of the arrangement point to the solstices, and when you're standing down here, the equinox sets directly over top of 3 prominent stones in the background. So some pretty interesting stuff happening there. We don't know how old the stone arrangement is, but it could be very old. Other sites in the area have been dated back to 11 to 14,000 years. If, and I say big if because again, we don't know, if the stone arrangement was that old, it would be the oldest stone arrangement anywhere in the world tied to solar positions. The oldest one we know of is about 7,500 years ago in southern Egypt.
There's so much knowledge encoded in the landscape. The landscape is literally telling a story, and there are lots of examples about how that links to the sky.
So I've only got about 3 or 4 minutes. I'm going to go a couple minutes over, but not too much. I've only got 2 more quick things to talk about. One is the antiquity of this knowledge. How long can this knowledge survive? We have oral traditions that talk about the Henbury meteorite striking the ground. That's 4,500 years ago. We've got oral traditions of the formation of lakes Eacham and Barreen up in the Atherton tablelands of Queensland that go back between 12 and 17,000 years. Is there any example we could give where, say, we use geological and astronomical evidence that coincide together very nicely to give us a very old date? The answer to that is yes, absolutely. the creation of Tasmania or Trowena. There are old oral traditions from the 1800s that talk about how the sun was a man and the moon was a woman. They rose and set together the first day. Back then, Tasmania was not an island. It was connected, it was a sandbank connecting Tasmania to the mainland. The sun and the moon gave birth to their children. The first one was Moani, which went into the sky as the Great South Star. The next day, Andromeda was born between Moani and the parents. I'm going to ignore all the other stuff, the old tradition, because we don't have time to talk about it. But looking at that, we get two bits of information that are extremely interesting. Number one, when was Tasmania last connected to the mainland? It's about 12,000 years ago. What about the South Star? If we look here at the map, there's a South Celestial Pole in the middle. There's no bright stars anywhere near this. The nearest bright stars, Achernar, Canopus down here, none that you'd really consider to be South stars. But the Earth does something funny. The Earth wobbles on its axis. So it turns on its axis like this, about 23.5 degrees, but every 26,000 years it does this, big loop around, which means where it points to the north and the south changes over time. If we go back to the last time Tasmania was last connected to the mainland, 12, 13,000 years ago, we call it precession is the name we use in astronomy for that wobble of the Earth. We notice that the second brightest star in the sky, Canopus, is only about 10 degrees away from the South Celestial Pole. So we have the second brightest star in the night sky. It's a great South Star. Discussed at the same time Tasmania was last connected to the mainland. That's about 12 to 13,000 years old. So how many people know that one of the stars in the Southern Cross now has an Aboriginal name? A few of you have heard of that. Excellent. I am a member of the International Astronomical Union. We're the society, the global society for all the professional astronomers. I am part of a small working group on star names. We're the ones tasked with officiating, yes, I know, officiating names for all the bright stars in the sky. Up until 2 years ago, there were no official names of any of the stars in the sky. The IAU is the only organization in the world that can officially name stars, and we didn't have any. They have what we call a Bayer designation. That simply ranks the star based on how bright it is. So Epsilon is the fifth letter of the Greek alphabet, so it's the fifth brightest star in Crucis, or Crux. Alpha Scorpii is the brightest star in Scorpius, that's Antares. So we put this working group together to go through and assign a popular name, one name, to all the bright stars in the sky. Most of them tend to come from the traditional Western, Arabic, Greek, Roman names. But we want to expand beyond that and start including names from indigenous cultures and ancient cultures around the world. At the end of last year, we released 87 new star names. One was a Burong name we talked about before, the Burong from Western Victoria. 3 of them were from the Wardaman people in the Northern Territory. One of those names is called Ginan. Ginan is the 5th star of the Southern Cross, this one right here. It represents a small dilly bag filled with songs of knowledge. So, I didn't think much of it when I was going through putting the list of all the Aboriginal star names together. Put to the committee, we decided which names to assign. A few of them were approved for this. Didn't even think in my head originally how significant it was going to be having an Aboriginal name for one of the stars of the Southern Cross. Then when we announced it, and I wrote a conversation article about it, it went quite viral. And then somebody pointed out, oh, all those Southern Cross tattoo sporting bogans are going to love the fact they've got an Aboriginal star name tattooed on them. So we ran with that full throttle. And we've got another batch of star names coming out this year. There's 7 more Wardaman names that are probably going to be recognized with that. So to finish up, what I want to talk about is the future of this work and what we're trying to do. It's great listening to some bloody American talk about this, but it feels kind of weird. For me as the researcher talking about it, and you as the audience, why don't we have more Aboriginal people leading this work? Several years ago, we didn't know of any Aboriginal people doing astrophysics at all. That's changed now. We have several now. So these are some of the students that we know of. This is Carly Noon is doing her master's degree at ANU. Crystal De Napoli is doing her undergraduate degree in astrophysics at Monash. Kirsten Banks is finishing up her undergrad in astrophysics at UNSW, and she's about to start her honors degree. And Willie Stevens was one of the people leading the Dreamtime Astronomy program at Sydney Observatory, along with Kirsten. So I'm happy to say we do have a new generation of Aboriginal students coming in and studying astrophysics. And one of these people is in the audience right now. So Crystal, would you like to come up and just tell everybody a little bit about yourself and, you know, how you've come into this work and what you're going to do in the future?
Hi everyone, I'm rather new to public speaking, so please bear with me. My name is Crystal. I grew up in a country town called Wangaratta, and as a student who was incredibly passionate about mathematics and science, and with those beautiful clear skies and bright stars, it was hard not to fall in love with astrophysics. I was very lucky to get in at Monash University, where it's one of the universities across Australia which actually allows you to have a major in astrophysics from the get-go instead of specialising later. I was also very fortunate to have incredibly passionate teachers who ignited this, little interest even further, and it's something that I'm so sure that I want to dedicate my life to. Throughout my initial studies at Monash University, my teachers would start to talk about some Indigenous astronomy, and unfortunately it was never a part of the syllabus. There is no unit or class you can take at Monash to specialise in this, and for me, it's such a shame. I am so proud of my culture. I absolutely love space, and the fact that these two things were so tightly linked, but I couldn't access that knowledge, it was something I was rather sad about, and even my teachers were. Like, they were trying to find out for themselves, they didn't know. By chance, I attended a convention to do with astronomy, and I was very lucky to meet Duane and to listen to what he had to say. And my whole reason to going to that convention was because I wanted this understanding and this knowledge, and I'd nowhere nearby that I could reach out to it. So I'm sort of jumping into it as much as I can, and it's something that I really look forward to specialising in, and to be a part of that collection of this knowledge from elders, the synthesising of it and the distributing of it. It's what I really want to work towards. For now, my goal is completing my undergrad and hopefully working alongside Duane on some of his research and being a part of that process. And yeah, that's me.
So very, very excited now to get Crystal working on a research paper on a topic that is yet to be determined, but we're going to find something. Carly and I are working on a paper on moon halos and how they're used as a weather predictor, so an entire paper about that one slide. Kirsten and I are working on a paper on planets in Aboriginal astronomy, how are planets described. I didn't really talk about that at all. Willie and I spend most of our time trying to kill each other in judo and jiu-jitsu, but occasionally, he's Murawari, which all three of these communities are all neighboring communities in sort of northern middle part of New South Wales. But I'm working with Willie to do a paper specifically on Murawari astronomy as well. So there's a lot of exciting stuff coming in. As time goes on, future talks I do, and the next talk that I give for the Society is going to be jointly with Crystal. This is an opportunity to start working with the students to get them up so they become the faces of the subject, and then these ugly mugs can go somewhere else while these students can come up and begin pushing forward with that. So I want to finish with this. The website has not gone live yet. My web developer and I are just finishing it up right now. So sometime within the next couple of weeks, this is going to go live. This is going to be a central point. Every bloody thing Aboriginal astronomy you can think of is going to be on here. You can follow us on Australian Indigenous Astronomy on Facebook, or the Twitter handle at Aboriginal Astro. Thank you very much.
Okay, so Duane has agreed to answer some questions. Mike is going to be the person who will take the microphone around. Mike with the mic. So, yes, the gentleman there first of all. Do you understand?
Also, if anybody has any questions for Crystal, I've told her we're going to do this and get her up here and ask.
Crystal, come up here. Come on, join us. Thank you.
Duane and Crystal, About planetary, I noticed you said you weren't going to talk about planetary, but I have read elsewhere about, and I believe it's correct, about the Torres Strait Islanders and their knowledge of the interesting fact that the evening and the morning stars are one and the same thing, which has enormous implications in many ways. Are you familiar with what I'm talking about?
Yes, that's the work I do with the elders up there. They've got different names for the morning and the evening star, but they do recognize that it's the same object. Wow. And that's not visible at the same time. There's a period of time between when it goes from morning star, then it disappears, and it comes up as an evening star. Now, what's very interesting is that there are a number of Aboriginal traditions from a couple of communities that we're working with that seem very well aware, not only are they the same object, but they know of the synodic cycle of Venus. So, you know much about the synodic cycle?
Yes.
A little bit, okay. Do you want to talk about it at all? No? All right. Unfortunately, this is something you don't, not really, there's a lot of areas of astronomy that are not really taught in undergraduate astrophysics programs. Like a lot of the naked eye astronomy, you don't learn that stuff. I never learned it as an undergrad. I had to learn it when I was a PhD student. But because Venus is closer to the sun than the Earth is, the Earth and Venus are in 5-8 resonance. So for every 5 orbits of the Earth, Venus goes through 8. And if you look at where Venus is, just like I showed the sun, the analemma, if you plot the position of Venus every night, you're going to notice it makes sort of 5 weird patterns in the sky that repeat every 8 years. The ancient Maya knew this very well, and they built observatories to measure the extremity points, the southernmost and the northernmost points. So a lot of Aboriginal cultures have special ceremonies about the morning star. When it goes from the evening star, they wait for it, and they know it's going to rise that direction as a morning star on a certain day. Now, to know the time and the azimuth, you can't get that just by guessing or hoping. You have to know. And when my old PhD advisor went up to Arnhem Land and asked one of the elders about this, is, how do you know when it's going to happen? The elder said, we count the days. People could count past 4, you know. It worked that way. There's numbers for, you know, words for quite high numbers, whole big numerical systems. So the Aboriginal people knew about the positions and the timing of Venus very well.
Can I just have one comment? It would be interesting to know that if the thought ever occurred to primitive peoples like that, that was an instance of heliocentrism, or was that totally beyond their ken? Because you're seeing Venus go around the sun, you see. You see the significance of that fact. I saw this look of horror on your face. Had you ever thought of that?
No, I don't use the term primitive when describing people.
Sorry.
So, I probably showed it a little more acutely than I wanted to.
That's what it was. Well, I'm sorry about that.
But I understand what you're trying to say. Look, there's a lot of different cosmological views. There's none that are homogeneous. There are a lot of different cosmological views. And, you know, some is the Earth flat? Is it round? Is it finite in space? You know, there was an old anthropologist who asked an Aboriginal person to describe it, and the Aboriginal picked it up and said it was like this. You know, sort of indicating it was flat, or that it was finite in space, and you know, we went around the sun, and the sun went around us, however you want to conceptualize it. And then, of course, other cultures said it was flat. But one thing I have to be very clear about, most of all the historical records we have about Indigenous astronomy, Aboriginal and Torres Strait, come from early ethnographers and anthropologists. I don't mean to bag on any anthropologist in this room, please, I'm not trying to do that. A lot of them didn't know their astronomy very well at all. They got a lot of that wrong. And almost half the papers I've published have been going back and correcting all their mess-ups. I'll say that nicely. Another thing is there's also a long colonial history of bias. So there were a lot of assumptions made that these peoples didn't know very much. And they were surprised when they seemed to know the cardinal points. Oh, hello, come on, that's not that difficult to figure out. You know, Aboriginal people knew this stuff very well. Is there anything you want to add to that?
The gentleman there.
I remember years ago reading that the people of the Kalahari on a cold, frosty, very clear night could hear the major white stars like Sirius and Canopus crackling and humming. Does that have you ever come across that? Sounds romantic.
Yeah. Not with stars. And, you know, with those things, it could be something cultural, it could be something in the environment they attribute to the stars. But there are a lot of traditions that talk about aurora making crackling, snapping sounds. And Aboriginal people talked about it, people snapping their fingers. And for a long time, up until a few years ago, scientists, astronomers, space physicists had no idea what this really was. And in the early days, it was just dismissed. Oh, these people didn't know what they were talking about. Turns out it is. It's some kind of electrophonic radiation, something. I don't know the physics behind it very well. I wrote a paper on it, I should know. But it's something that happens more at the ground level. It's sort of electrophonic sounds that causes crackling bits. So some researchers went up into the Arctic and did some work on that. So yeah, this is where there are lots of examples where if we look at Aboriginal traditions, that can actually help physicists and astronomers with our research. You know, the variability of Betelgeuse wasn't recognized until, I was getting mixed up, was it William Herschel or his son? One of the Herschels observed it in 1840 and figured out it was variable. Well, these stories were recorded before that. Aboriginal people knew that before. So if you had looked at their traditions and knew what they were talking about, they could have told you the stars are variable beforehand. There's stories about bright stars appearing in the sky, right there in the sky. Well, guess what? Later on we find, oh, there's a supernova remnant. The Chinese wrote down there's a bright new star appeared there. Star went supernova. These old traditions could tell you about that if we looked at them. So as scientists, we have to get over our arrogance that we think we know it all and that we think we know the best way and start working with communities and learning about this stuff, because there's a lot that we can learn from communities, not just the other way around.
How much do you think that was lost with time because of, you know, the reduction of the population, and also because there's no material that was written, like just because that was the story that was told to one to another? Do you feel like that probably they knew much more and actually we will never know that much, like what you are feeling about this?
You want to go with that one? That's all right.
Like, I feel like there's many effects made by colonization, and unfortunately I do believe that would be a side effect. It's something that we can't determine, we won't be able to really backtrack and figure out now, and unfortunately that's something that we have to move on from. We have to try and work on what we do have, try and expand on that and make sure the conversations are still happening. Don't undermine any of the information that you're hearing and try and find where it fits. But unfortunately, colonization, it was devastating. There are massive effects that can't be unchanged. And unfortunately, that's sort of where I see it being.
I think it is important to note, a lot of places people think that knowledge is lost, it's gone. In some places it is. A lot of places it's highly fragmented, to say the least. But there are a lot of communities where the knowledge is still there. My time in the Torres Strait, I've had 4- and 5-year-olds come up and start. I was at the beach one time, and I had just given a talk to the school. Some kids saw me at the beach. They're like, oh, you're that astronomer guy. Oh, yeah. And they come up, and they start asking me questions about, but they're not asking me to learn. They're asking to interrogate. And when I say, I know what that star is. You know what that star is? He's like, yeah. Well, this is, and then I remember being blown away. He starts naming all the stars, the Western name, the Merriam-Mir name, what they mean. I'm just thinking, good God, this kid knows astronomy better than most of the physics students I've taught. And I said, how do you know this? He says, my dad taught me. So this knowledge in a lot of communities is still being passed on. There's a serious distrust of academics, white academics. They refer to it as here come the anthros, or here come the archaeos. It's a non-stop, never-ending stream of anthropologists and archaeologists, usually PhD students, like I was, who come in a community all fresh-faced. They want to sit and learn about all the knowledge they can. So the elders sit, talk about all their knowledge. The student takes off. They write books. They publish material. The elders never hear from them again. Government policy is usually passed, oddly enough, always against the Aboriginal people somehow, using that same knowledge. There's strict ethical protocols now. We totally rearranged how we do that kind of work with communities. It's more collaborative now, of course. But because of that long history, in some places that still happens, there's a lot of distrust. So you ask people about it, either they'll be like, we're not going to tell you. They'll be like, no, we don't know anything about that. No, it's gone. But then you find out they got plenty of knowledge about that. They just don't want to tell you because they don't want to get ripped off.
We've got time for 2 more questions. The lady in the back row, Mike, turn around 180 degrees.
Hello, there you are.
And the gentleman over here, that'll be the last 2 questions. After those questions, there'll be a few words, then we'll all go down for some supper and a chance to have further discussion. So, lady there.
Yeah, 2 questions. You Are there things that that Aboriginal people know about the stars that aren't related to any story? That it's just kind of abstract knowledge that you know there are 50 stars there or something like that, and it doesn't mean anything particular. And the other thing that you talked about were the except to be part of a knowledge base. The other thing that you talked about were the number of levels of understanding. What would be an example of sort of the highest level of understanding of a particular event or star or something?
Quite a few of the things I talked about was that kind of abstract knowledge. The stars, for example. That song, the Twinkling Stars. That song that I played was composed in 1965 by George Passy. That's not a super ancient song. They have old cob car, old traditional songs. That was more of a contemporary song. They didn't tell me a story that connected that together. They just sit here and tell me this is what we look for and how that's used. So they very well have a lot of abstract knowledge about that. It's just sort of factual information you tell. And the second question was about levels of knowledge. I don't know. I mean, I know there are people who know detailed bits of knowledge, and every once in a while, some of the elders will just sort of, almost a little bit off the record, start to give me a little bit more. And I've had one time, he just started telling me, okay, what about this? And he starts railing into all this knowledge. And I didn't have time to write it or record it, and that was on purpose. But I was like a tsunami of information. And he's like, here's the levels, you've learned this much, that was here. Like, you're not even close to knowing those top levels of knowledge the senior elders know. And it's like a pyramid. As that knowledge gets higher and higher, fewer and fewer people know that. I mean, knowledge is power, right? Those top couple levels, only I don't know, a handful of people know that really high-end knowledge. And it's very restricted and very secretive. Is there anything you want to add on that?
No. Last question from the gentleman there.
Oh, yeah, hi. When you were talking about the mistrust of, I guess, colonial white academics, whatever you want to call them, us, was this, I wondered, is there something about you being American or, not from Australia that maybe got past that a little bit for you?
Yeah, I think they recognized I wasn't Australian. I didn't have a lot of baggage in that department, so to speak. I mean, we've got plenty of our own baggage in America. I didn't have that here. That helped. There have been a couple times where I'll have to admit that you make a mistake because you don't know a lot about what the protocol, and sometimes you make a mistake, and it's pretty easy to pass myself off as a bit of a dumb American sometimes. Like, oh, I didn't know no better, sorry. But as a whole, most of the research group I have are not Australians. I mean, they're technically Australians. They're Australians now, but two of us are originally American, two are British, one's Portuguese. We've got a few Aboriginal students. I've been contacted by 3 more, one from India, one from Malaysia, one from Spain. There's a bit of a theme going on here, I'm noticing. But I will say, and this will be the last bit of rambling I do, one of the most terrifying and humbling experiences I ever had, which is especially relevant considering the last week, I was up on the Torres Strait talking with some of the students, and they heard my accent, and they were very excited, And I was talking to them. I was like, I was 20 years old the first time I saw the ocean. Whoa! They couldn't believe that, And they started asking me questions. So, Dr. Duane, have you been to New York? I've been to New York. Wow, that's so cool. I'm like, these kids think I'm awesome, right? Have you been to LA? I've been to Los Angeles. Oh, wow. Chicago? Yep. And every time they do something, I'm sitting here, it's like, yeah, these kids think I'm awesome. This is great, yeah. Like, oh, so do you have a lot of guns in America? Yeah, we do. Oh, okay. So is it true? Do you shoot people like us? You talk about going from this to this. And this wasn't a kid trying to get me in a gotcha moment or something like that. They were genuinely just excited and genuinely interested. Because this happened right after all the Ferguson stuff. Ferguson is in St. Louis. It's an hour and a half away from where I grew up, in Missouri, So I just went from feeling like I was about 9 feet tall because these kids thought I was, cool as hell. And the next thing I know, I'm just feeling like I'm this big. That was a pretty humbling experience. I know it doesn't have anything to do with astronomy necessarily. But as an American, in a remote community out in the middle of the Torres Strait, having some kids ask you that question was a pretty, I don't even know how to describe it other than a humbling experience. So being American has its unique chemistry when doing this kind of research, to say the least. But that's also why, we're working with Crystal and Carly and Kirsten and students like that to bring you guys up, so you're doing the work with your communities. Because a lot of this information I talked about here, it's your mob, it's Gamilaroi, So people like Uncle Gil or Michael Anderson, who's one of the senior elders who I've put you in contact with. He's one of the founders of the Tent Embassy, in fact, the only surviving member. So he'll get back to you soon. I'll just call him Uncle. Oh, come on, student. But there'll be a lot of knowledge sharing there, and it's great to just sort of get you guys connected on that. So you can pass the torch on, which seems really weird, an American guy passing it on, but we'll get that. So you guys are taking over, and I can go off and do some other stuff elsewhere. It'd be great.
Thank you very much. Just a second. Thank you very much. As my colleague Sophia Frentz comes down to move the formal vote of thanks to Duane, I'd like to thank Crystal for joining us up here. Your public speaking was very eloquent and excellent, and don't worry, you're fantastic. Thank you very much indeed.
So that was a fantastic talk, and I'm really enthused by this incredible whistle-stop tour through naked eye astronomy and Indigenous knowledge from Australia. And I know that next time I get away from all of this light pollution, I will definitely be looking for the emu in the sky and other things that you mentioned tonight. So it was just really a fantastic talk, both from you and from Crystal, and I'm looking forward to you being more involved in the next one of these. So because of all of that, because this has just been wonderful, and no wonder it's been so heavily oversubscribed, thank you so much. I'd like to move a formal vote of thanks for giving this talk and for coming here and being part of the Royal Society tonight.
Ladies and gentlemen, thank you very much for joining us tonight. We have two more presentations that Duane has graciously agreed to give, and with Crystal, thank you very much for being roped into this as well. And if you want further information, I think we're going to put it up on the...
Facebook and our website, please.
Yeah.
We'll get up there.
Yes, and so you can tell your friends and colleagues about it. Duane, there's one other person that I'd like to thank, and that is, well, actually two. I'd like to thank your teacher at school, and I'd like to thank the person who ticked the box that allowed you to come to Australia on your study abroad. Both of them, I think, have contributed significantly to what has happened tonight, and it's a real pleasure to meet you and Crystal. Thank you very much indeed.
For tens of thousands of years, Aboriginal people and Torres Strait Islander people have paid incredibly close attention to the world around them, and still do today, have developed knowledge systems that are more complex than we could ever imagine, are as intellectually capable as anybody else, if not much more, and that their traditions have a very detailed scientific component that we can learn from if we just shut up and listen.
There was an excellent talk by Duane Hamacher. He covers a lot of interesting areas there of Aboriginal astronomy. So thank you especially to the Royal Society Victoria for giving us permission to screen that, and that will also be up on our YouTube channel for looking at. Right, we'll break now for a tea break for 10 minutes, and then we'll start at quarter to 10 in here again sharp. So if you haven't got your tea at that stage, feel free to bring it in and drink it in here. Thank you.
Okay, it's counted down now, please. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, take off. Title, please. I need the title page. Back one. Thank you. Okay.
everybody. Hello.
Hello.
After last month's talk, Pie in the Sky, I thought I was just going to have fun inventing some new title, Fire in the Sky. And that was before the Victorian bushfires. Please notice that the sound clip that we just heard is actually extremely interesting because it actually came from the light curve waves from a star. And there will be a little bit more about this at the end. Next slide, please. Thank you, President. When I started this preparation, I was thinking about an Aboriginal story about a campfire. So I had just one fire in the sky. And then it just grew and grew, these stories, sets of stories, into a supernova later. But let's see the first little fire, the battle fire. Some Aboriginal stories, and notice that I am quoting the previous speaker's work. Battle fire between our favorite star, Betelgeuse, and Aldebaran. And please notice here as well the winter hexagon. Of course, it's summer hexagon for us, for all the bright stars. So lovely. Have a look. They're fighting. That's the US and that's Iran. Then all these campfires. This is the loveliest image, I think. Look at all the great river of the Milky Way and all the campfires around. Okay, next slide, please. Meteor, one of the most exciting fires in the sky. This picture is from 2013 in Russia, but some Aboriginal stories refer to the first-hand experiences of meteor. Now, not being an Aboriginal, I'm not allowed to, and I shouldn't tell any stories of theirs. But I hope to have forgiveness for mentioning just little bits to further the awareness and the understanding. Quoting, for example, this one is actually Hamacher's thesis that is publicly available and you can download yourself. So Greg has escaped me. He's afraid of me volunteering him to read materials. He'll tell you all about the Henbury crater. Some other stories. The falling star.
The falling star will cause the earth to shudder, the hills and trees to topple and turn, and everything going black with night descending.
Thank you so much, Ross. Part of the reason why we have this spot, which Peter calls a segment, I laughed at that. Part of the reason is to involve the members and have people step forward, upskill, and also teach us how to speak as well, so we share the load. So you'll be most invited, most welcome to come and take my place. Not tonight though. Next one, please. Comet. This may be one example of the situation where there is smoke, but there's not necessarily a fire, but ice. The Great Comet of 1882 may be related to some of the original stories, as they saw the comet as smoke of a campfire. Next, please. This was actually the time that I was looking at the missiles or reports of missiles in Iran. And I thought, do people realize that meteor showers, meteors can be shooting in all directions? It may not be a missile at all. And that was actually the meteor shower just past the quadrantics Okay, next one, please. This picture shows, see these meteor showers? The same one, quadrantids, taken from the ISS by an astronaut. I purposely blocked out the city lights around here, so if you look her up, you see that there is a bright splotch here, city lights, and she mentioned the northern lights as well. Next, please. So we have the southern lights here. Not only here, but there are traditional people and stories in New Zealand as well. One Maori story saw this as a reflection of fires cast by their ancestor. Again, I'm quoting Hamacher, a different piece of work. Next, please. Now the sun. Have you seen the sun at all in the past few days? I didn't. I only saw some weird orange thing up there. The same astronaut posted these, the picture during the solstice. I thought that was magnificent. There's also a collection of stories about the sun, of course. One story refers to the Sun Woman. We have a volunteer here. Yes. The Sun Woman!
I'll jump up so I don't have my back to anyone. Right. The Sun Woman lights a small fire each morning, which we see as the dawn. She paints herself with red ochre, some of which spills onto the clouds, creating the sunrise. Lovely. She then lights a torch and carries it across the sky from east to west, creating daylight.
Oh, thank you so much. Please welcome the next speaker. Thank you. Next, please. And from the sun, our sun will explode soon and become a supernova. So this is just one example of what we can see here in the Tarantula Nebula, the 1987A. Okay, next please. And when we have a supernova, we have the remnant, all these clouds and things. This slide I prepared especially because one visitor here asked a question. All these pictures we see like this are the lights from some active source or something else. And the answer would be, I think Peter explained all that, there are different kinds of nebulae. And there won't be time to go into all these, and also I don't know much about them, so I have to look up each time. But something special here is that some object in the sky, actually something that I really love, that's Eta Carinae, has a collection of all of these types of nebulae. Now I'm trying to say these in a different way. Eta Carinae, Eta, the Greek way, and Carinae, the Latin way. Why is this so interesting? There is an overwhelming probability of something. Please?
Eta Carinae. The overwhelming probability is that the next supernova will originate from an unknown white dwarf or anonymous red supergiant, very likely not even visible to the naked eye. Nevertheless, the prospect of a supernova originating from an object such as Eta Carinae arouses great interest. One of the two main stars of the Eta Carinae system is expected to explode as a supernova in the astronomically near future. Why?
Oh, thank you so much for great questions. Why? I mentioned the light curve and the sound clip before. This is the light curve of Eta Carinae by VSO. And please see that the light curve that goes up and down like this over years and years reminds us also about what we're talking about these days, the Betelgeuse dimming. And people are expecting that it might just go up, but Eta Carinae is already up, and this is 2015. I just looked up this morning, 2020 is up here. So something exciting is happening with this particular place. Also, some people have heard me rave about spectroscopy previously. This is from Hubble, Eta Carinae spectroscopic data. Something exciting about this I won't have time to go into. But I'm hankering that someone will ask me to speak about that. Next slide, please. So this is my last slide. I am passing the message to us Southern Sky stargazer, including myself, to be reminded that millions and millions of people observing objects in the northern hemisphere, they can't see objects like this. It's our watch. It's us. If something happens here, it should be reported by us. So let's get together and team up and keep observing and monitoring these objects. And how can we help?
Can we help with Eta Carinae? An example from 2019. Eta Carinae visual observations were needed, and an active Eta Carinae researcher called for help on the aavso.org website. So that's the American Association for Variable Star Observers. And Eta Carinae underwent a 0.15 magnitude rapid brightening, and experienced variable star observers can readily determine a 0.1 magnitude change just by their eye. You don't need any instruments at all, just your naked eye. And so please look up variablestarsouth.org as well, which is the organisation that gathers observations of variable stars for the Southern Hemisphere. The AAVSO does it globally, but Southern Hemisphere is done in New Zealand through the Variable Star South.
Thank you, fantastic volunteer. For other people, for people who do not know, Peter was very active in organising some of the observations everywhere around here. So he's the expert. We shouldn't waste him as a president at all. He should be producing data. Okay, if nothing else, I think I have succeeded in having volunteers contribute and be up front. So I'm really proud of that, and I hope that you enjoy this little talk. Thank you. Sky out.
Mark, please.
It's on the wrong side. Yeah, I just turned the slide on. No signal, great. There we go. Hope that helps.
Okay, everyone hear me okay? All right, so Sky for the Months, it's been rather interesting, all the previous speakers have sort of brought up things that are going to come up in this presentation, so hopefully they haven't all stolen the thunder. Right, one press. All right, January, February 2020 highlights. I've done the January ones and the February ones because by the time the next meeting occurs, we're well into February. Really, the highlights out of the book were not all that specky this month, apart from Pluto in conjunction with the Sun, which that means it's in the same position as the Sun, so we're not going to be able to see it. Not that it's all that easy to see anyway. The moon at perigee, I've included that one there. The moon being at perigee means it's actually at its closest point to Earth. So, supermoon, I suppose you could call it. The new moon occurs on the 25th of the 1st, and on the 30th of the 1st, moon is at apogee. And that means it's at its most distant point from the Sun. Thanks, Rick, all right. The other thing I've included in this slide too is Vesda is 2 degrees south of the moon. Now, Vesda is one of the asteroids. I've actually got a table of the asteroids that are in opposition this month, but given most of them are around about 8th magnitude, they're not really naked eye objects. Mercury reaches full elongation east on the 10th of the 2nd. Basically means you'll need to get up early in the morning because its elongation is east. We only see it in the evening sky when it's elongation or its maximum elongation west. Juno is another asteroid, and Ceres also. Now, Mercury, you'll see there's at inferior conjunction on the 26th of the 2nd. That basically means it's between the Earth and the Sun. So it's in conjunction with the Sun, and obviously if it's on the other side, it's superior conjunction. On the near side, it's conjunction. So the sky looking south, and I think it's very interesting some of the things Sky raised there, because anyone wants to have a look at the Carina Nebula, it's up here near the southern Pleiades. Alright, just above the Southern Cross. So if you're looking through the Carina, there's the Milky Way. So it's halfway between the Southern Cross and the False Cross. It's quite easy to see. It can be seen with the naked eye. So it's a good one for particularly newer members to have a crack at. A lot of these ones are quite easy. Over here, you'll see this ghost of Jupiter, and that is a planetary nebula. Now, essentially what a planetary nebula is a star that has burnt all of its fuel, sheds its outer, it's not a big one, it doesn't supernova, it's not a specky one, but it does shed its outer layers. And when you look at Ghost of Jupiter through a telescope, it looks very similar to the planet Jupiter, and hence the name it's been given. And that's in the eastern sky. Now, when I say looking south here, we're looking that way. So we're looking into all the trees and the building to the south there. So things like Omega Centauri, which is a globular cluster, the brightest one in the sky, tends to be behind the trees at this time of the year. So we really need everything to turn around a bit so we can see it. Now with the Southern Cross there, just below Mimosa, which is the second brightest one in Southern Cross, is the Jewel Box cluster. It's an open cluster. It's called the Jewel Box cluster because it contains stars of multiple different colours. So another quite a good one for newer astronomers to try and get. It's fairly close to Mimosa, so quite easy to actually spot. Other things up there, for those who can't get Omega Centauri because it's below the trees, probably the second best globular cluster is 47 Tucanae, and it's just below the southern Small Magellanic Cloud. Now, Small Magellanic Cloud itself is an irregular galaxy, actually outside our own galaxy. So if you want to look at a galaxy, have a look at that one. Although the large Magellanic Cloud is better, and Sky also mentioned the Tarantula Nebula, which is actually in that galaxy. So you can get it with a telescope. It's quite observable, particularly with the scopes we've got here. And It's a bit of a favourite with the astrophotographers because it does come up quite well in astrophotography, and it is actually in another galaxy. So think about that when you're looking at it. Okay. Looking to the north, we notice goes from Jupiter swings over to the eastern sky there. So if we're looking that way, it's out in this direction. N44, which it says there is Presidio, it's actually also known as the Beehive cluster. It's an open cluster, another easy or reasonably easy one to get. Although Cancer's not a particularly bright constellation, but it isn't all that far from Canis Minor, which you'll find with Procyon. All right, and that's down below Sirius. Over here, we've got the Orion, with the Orion Nebula, which is in whatever he said that was. Apparently it's not his sword. Okay. Betelgeuse, we see Orion upside down, so Betelgeuse tends to be the shoulders of Orion, which are underneath at the moment. So worth having a look at, might not be here next week. Other clusters, there's also an open cluster, M67 and M35 down here. So there's a little bit of deep space stuff or deep sky stuff to have a look at, particularly for the amateur astronomers. Well, we're all amateurs. But the newer astronomers, because some of these things are quite good through a telescope, they're quite easy to spot. Okay, you haven't seen this before tonight, have we? Okay, that'll teach me for going last, won't it? Okay, as everyone who's looked at the MPAS emails would realise, Betelgeuse is dimming. And Sky showed us that it is actually reducing, was it you? Someone did, yeah. And the potential for that is, because it's a super red giant star, it's probably going to supernova. Not probably, it's going to supernova. I was a bit disappointed to read somewhere where in astronomical terms it could mean sometime in the next 100,000 years. So I would like to stick around for it, but what I was saying. This is Orion, pretty much how we see it in the southern hemisphere. Rigel is the bright one now. It is actually Beta Orion's, which meant it was usually the second brightest. Betelgeuse is at the other end. Okay, so if you want to go out and observe a supernova, go and stand and stare at that for the next 100,000 years, and you've probably got a good shot at it. All right?
Then again, it could happen tomorrow.
It could be tomorrow, yes, you might just get lucky. And particularly for the newer members, that's where the Orion Nebula is. So, what are the planets up to? Okay, Mercury, superior conjunction on the 11th. That means it's on the far side of the Sun, but we can't see it because the Sun's in the way. It'll return to the evening sky, but apparently they reckon it's going to stay fairly low in the Sun's glare, so not going to get a really good look at Mercury this time around. Venus, well, it happens to be that, if you can actually see the sky at any time at the moment, is that big bright object out in the western sky. It approaches its maximum elongation in March, and if you remember from last month, maximum elongation is the maximum angle between the Sun and Venus. So it's come around the Sun, and it's out as wide as it's going to get on its orbit. So very good viewing position, and when it gets to its maximum elongation, you will see it as basically a half. All right, because you'll see the dark half pointed away from the Sun, the other half pointed to the Sun. Earth was at perihelion on the 5th of January, which is its closest approach to the Sun. All right, that's why the southern, it happens every year at this time, that's why the southern hemisphere summers are hotter than the northern hemisphere summers, because when the northern hemisphere has its summer, we're at perihelion. We're at aphelion. So, helium mixed up. Mars is currently in Scorpio, and then moves into Ophiuchus. I think that's how you pronounce it. During the last half of the month, it is essentially a morning object at the moment, and it will reach opposition in October. And apparently this year it's not going to be quite as close to the sun as it was last year. So for those who looked at it last year, all you saw were sandstorms. So you're a little bit hopeful this year you'll get to see a bit more detail on it when it's in opposition. Now it doesn't actually move into opposition because where it's placed, Earth is chasing it, and we come around and we move between the Sun and Mars, which places Mars in opposition. That occurs in October. Jupiter is in Sagittarius. You'll need to get up early in the morning to see Jupiter. It's just gone past conjunction with the Sun, or rather it's just gone behind the Sun from where we are. It'll pop out and you'll need to get up in the morning if you want to see it. Saturn's pretty well the same. It reaches conjunction with the Sun on the 14th, so probably won't be able to see it. It won't reappear until February. And once again, it'll be a morning object. And gradually, as we move around the Sun much faster than those two planets, we'll eventually catch them, and they'll move from conjunction into opposition, which later in the year, they'll be better to have a look at then. Uranus can be found in Aries, not exactly the fastest moving object in the sky. It takes 84 years to go around the Sun. So it's going to be in Aries until 2024. So for those who want to have a look at it, you just need to figure out where Aries is. You've got 4 years, all right? Okay. One of the things it did cease was retrograde motion. It tends to drift. The planets normally will drift east against the background stars, but because of an anomaly of where Earth is and we're moving faster, sometimes they can appear to move west against the stars, and that's called retrograde motion. I'll talk about that a bit more another day. And Neptune, found in Aquarius, it's going to be there a fair while, I'd say too. Low in the western evening sky. Both of these are up at the moment, moving. Neptune slightly ahead of Uranus. Really, it is only a blue dot through most of the scopes I've looked at it. And but on the 28th, it moves less than a degree from Venus. Now, if you hold your arm at arm's length, you look at your thumb, that's half a degree. So less than 2 thumb widths, and it's going to have the 4th magnitude fire query between the 2 of them. So might be a nice little one for the astrophotographers to try and get all of those. The appearance of the planets. Mercury is in superior conjunction, so it won't appear at all. When it does, we'll be looking pretty much at the full face of it. But really don't hold your hopes up of having a good look at Mercury. Venus, it's still approaching its maximum elongation, so it's still, Sun's there, it's still over here relative to us until it moves into elongation here. So we're still seeing a significant amount of, well, 3/4 of it. Mars still fairly small. That will expand, get bigger as we approach opposition later in the year. And as I said, it is a morning object. Saturn, still magnificent, so is Jupiter. You just got to get up at a horrible early time to see them. And Uranus and Neptune, not so specky. And that's Pluto there, all right? Given it's in Sagittarius, good luck picking it. Pluto's in conjunction with the Sun on the 13th. That basically means it's hiding behind the Sun, so really probably don't bother this month. Now, dwarf planets and other smaller solar system bodies. If you have a look down that list, they're the list of asteroids that reach opposition. Basically means on the other side of Earth to the Sun, we're on our closest approach to them. 3 of them are in, wrong one. 5 of them, sorry, are in Gemini. So I reckon if you can get Gemini in your camera lens, take it over a few nights, and pick which 5 move, they're probably each one of them. So looking at the magnitudes of the right-hand column, don't expect to see them with your naked eye. All right, probably not so much for the newer members, but the older show-off members, they can have a crack at those. Okay, and finally, just one thing doing the public nights that I find people really boggles their mind is when they start thinking about what they're looking at, how far these things are away. So just a few examples of astronomical distances. To the moon, 1 light second. Alright, so basically when you look at the moon, you're seeing it how it looked 1 second ago. So probably not a lot of change. The sun is 8 light minutes. Alright, so the light you see from the sun or receive from the sun has taken 8 minutes to get to us. Now that basically means if you get up really early and you watch sunrise, as it hits the horizon, start your stopwatch. And in 8 minutes, have a look where it is. That's where it was when you actually saw it rising. To fly across the planetary solar system, in other words from the sun to the furthest planet, take you 4 hours, 4 light hours. So any light coming from Neptune has taken, we're 8 minutes, so it'd be what, 3 hours and 52 minutes to get to us. So even when you look at Neptune, you're starting to look at stuff that is light that's left us a fair while ago. Alpha Centauri system, the nearest star system. They call it a system because it's actually a triple star. 2 reasonably bright ones, about the same as our sun, and a little red dwarf known as Proxima Centauri, which actually, depending on where it is in its orbit, is the closest star to us. It's 4.3 light years. So what you're looking at when you look at Alpha Centauri is what it looked like 4.3 years ago. Sirius, 8.6 light years, so twice as far as Alpha Centauri and a hell of a lot brighter. So basically, it must be pretty big to be showing up as it does. But when you look at Sirius, that's where it was, how it looked 8.6 years ago. The Pleiades, open star cluster, otherwise known as the Seven Sisters, over near Taurus, is 430 light years away as a cluster. That's probably an average because I don't think every star is exactly that. So the light you're looking at from there has taken 430 years to get to us. So when you look at it, it left long before any of you were born, except for Patsy and Sullivan. I can say that because he's not here. Centre of the Milky Way, 25,000 light years. Now, given the Milky Way is about 100,000 light years across, we're obviously about halfway up on one of the arms. Okay, so it basically means if you want to get out of the galaxy through the arms, you've got to do another 25,000 light years before you'll leave the galaxy for interstellar space. So I would suggest you go up instead of sideways. And finally, the Andromeda Galaxy, which is quite visible. Greg recently took some photos of it and put them up to show. That's 2.3 million light years away. But apparently it's getting closer because it is on a collision course with us. Not going to hang around for that myself, but I reckon nothing.
4 million years apparently.
Okay.
It's 300 kilometres a second towards us.
Already?
300 kilometres a second towards us, Andromeda.
Yeah, Andromeda. Apparently not a collision course with us.
300 kilometres a second. That's what it's travelling at.
Okay, and all tonight's information was provided from Astronomy 2020, which is that book there. For the newer members, there are still some on sale, so anyone interested, see Simon at the end of tonight. Okay, any questions? I'll try putting it in properly next time.
How do you like the way it smells?
Right, this is the first of 3 videos. This one is given by a historian about animals and their role in the space race. So hopefully I can get some audio coming through.
The rocket designs and support systems. Sadly, many of those making animals never made it home. The courage and sacrifice of the US and Soviet space animals is history that deserves to be remembered. One of the United States' first animals in space was a 1-pound squirrel monkey named Old Reliable because of how quickly he picked up on training at the Navy's Aviation Medical School in Pensacola, Florida. The US chose squirrel monkeys because of how sensitive they are to their environment, making their biological responses to the stresses of being in space easy to monitor. Before the Jupiter AM-13, bearing Old Reliable's capsule, blasted off at Cape Canaveral on Friday, December 13, 1958 at 3:38 in the morning, the scientists renamed the monkey Gordo, which was an easier name to pronounce over radio communications. He was equipped with a plastic leather-lined helmet strapped to a custom-built couch with medical monitoring equipment. Gordo survived 9 minutes in space, but was lost when his capsule splash landed in the ocean and the beacon that signaled the waiting rescue ship did not go off. Despite the loss, the mission was considered a success. Scientists believe, despite not being able to find him, that Gordo survived the landing and that a human could have done the same. Numerous monkeys and apes of several species were flown by the US in the 1940s, 50s, and 60s. About 2/3 of all the monkeys launched in the 1940s and 50s died on the missions or soon after landing. While the US was primarily working with monkeys in their space program, the USSR had a different animal of choice: dogs. The Soviet space program utilized all-female dogs because they were believed to be easier to handle. They used animals picked up as strays from Moscow streets because they thought that those animals could bear hunger and extreme temperatures more easily than house pets. The Soviets were launching suborbital flights with dogs inside them as early as 1951, using R-1 rockets. Pups with names like Desik, Sigan, Malishka, and Zib successfully ventured into the upper atmosphere, and most returned to tell the tale. Zib was particularly interesting. Usually Soviet space dogs received extensive conditioning and training before being launched, but Zib was picked up off the streets because a dog named Bolik, who had been trained, managed to escape and run away shortly before her flight. Zib is actually an acronym for the Soviet words for replacement for missing Bolik. Despite receiving virtually no training, Zib completed her mission and returned safely home. Another Soviet dog made history by becoming the first animal to orbit the Earth, a 13-pound stray named Laika. Originally called Kudryavka, or Little Curly, the international press gave her the name Laika, or Barker, after her introduction by Russian radio to the adoring public, in which she barked into the microphone. After the successful launch of the first satellite in space, Sputnik, on October 4, 1957, Soviet scientists were tasked with creating a satellite to carry a dog into space. Soviet leader Nikita Khrushchev requested that the next history-making satellite blast off on the anniversary of the Russian Revolution, which was November 7th. With this tight deadline of less than a month's preparation, scientists were pressed for time on designing Sputnik 2. Chosen partly because her white fur with dark spots reproduced well in black and white photos, Laika was extensively trained for her flight, along with a second dog named Albina, which translates roughly to Whitey, and another dog named Muka, or Little Fly. Muka was used to test the systems on the rocket, including life support. Albina was Laika's backup in case anything went wrong. Though Albina may have been a better candidate for the flight than Laika, because she'd already flown in a high-altitude rocket twice before. But Albina had a litter of puppies, and scientists were reluctant to send her on the mission. They already knew the dog they sent into space would not be coming home. The equipment to safely return a living creature from orbit had not been invented yet. The capsule would only be equipped with 1 day's worth of food because scientists weren't certain the dog would be able to eat it all. There were also concerns about weight. The first Sputnik, launched the month before, weighed about 40 pounds. Sputnik 2 would weigh an astonishing 250 pounds. Laika was outfitted with extensive biological monitoring instruments through surgeries and a special waste-eliminating suit created just for female dogs that took training for the animal to get accustomed to. She was kept in smaller and smaller boxes to prepare her for the restrictive space capsule and trained to sit calmly for a long time. Laika was also run through centrifugal simulations to prepare her body for the stresses of spaceflight. It must have been difficult for Russian scientists to send the famously even-tempered Laika off to her death. Adelia Kudryavskaya, a scientist on the mission, said, "Before Laika's mission, I was crying. We all knew in advance that she would die. We were asking her to forgive us." Critics at the time protested the use of Laika. The National Canine Defense League of the United Kingdom asked all dog owners to participate in a minute of silence for Laika. Some animal lovers protested in front of Russian embassies. Before lunch, one of her handlers took Laika to his home, and his children spent a few hours playing with the dog before the flight. One of the people who prepared Laika for the flight later said that as she was strapped into the capsule, someone kissed Laika's nose and wished the dog bon voyage before shutting the door. Laika blasted off on November 3rd, 1957, in an R-7 rocket. After surviving the unbelievable gravitational pull of takeoff and making it to orbit, the jubilant Soviet scientists sent the message, "Alive! Victory!" to authorities for distribution through the press. At the time, the official story circulated suggested Laika was alive for a few days in orbit and had died a painless, pre-planned death. It was not until 2002 that scientists shared with the world that she probably died from the heat and stress only a few hours after the flight began. Laika's capsule orbited the Earth over 2,500 times and burned up when it re-entered the Earth's atmosphere the following April. Skywatchers in the United States reported UFOs and bright lights. What they were seeing was Laika's return to Earth. Oleg Gazinko, one of the scientists to work with Laika, expressed dog lovers' opinions about her loss. He later said, "The more time passes, the more I am sorry about it. We did not learn enough from the mission to justify the death of the dog." Laika has been memorialized in popular culture, children's books, films, and stamps. In 2005, NASA named a soil target on Mars, part of the Mars Exploration Rover mission, Laika, because of her contribution and sacrifice for space travel and humanity. It would be almost 3 years since the flight of Laika and Sputnik 2 before the Soviet Union's Institute of Aviation and Space Medicine would again send dogs into space. The dogs on the next flight were named Belka and Strelka, and they would not be going alone. Soviet scientists also sent rats, mice, a rabbit, fruit flies, and plants with them. The primary aim of the mission was to gather intelligence regarding the physiological effects of space flight, information that would be used to determine whether or not short-term exposure to weightlessness seriously impacted basic bodily functions. Belka, which translates to squirrel, and Strelka, little arrow, were small, like Laika, but unlike their unfortunate colleague, their capsule was equipped with parachutes. Cameras were installed in the capsule to record their every move. When Sputnik 5 reached orbit, neither of the dogs were moving. However, after the 4th time around the Earth, Belka vomited, and both dogs began to move and bark. After they circled the Earth 17 times, the successful pair returned to Earth and became almost instant celebrities. The taxidermy pair may be viewed at the Museum of Cosmonautics in Moscow. A year after the flight of Belka and Strelka, Yuri Gagarin became the first human to orbit the Earth. Shortly before he did, a dog was sent into orbit along with a dummy shaped like a cosmonaut. Gagarin was said to have joked that he was unsure if he was the first man in space or the last dog. The Soviet dogs continued to make history when Ugolyak, Cole, and Veterok, Light Breeze, orbited the Earth for 22 days in 1966. Their length of time in orbit was not beaten by humans until the Soyuz 11 mission in 1971, and is still a record for canines in space. And while animals in space offered valuable information that was necessary in order to facilitate manned spaceflight, they also made a unique connection at a critical time back here on Earth. Though the US and Russia were heavily engaged in the Cold War, President John F. Kennedy and Soviet leader Nikita Khrushchev knew each other well and often exchanged gifts. One of the most interesting of the gifts was a small white dog named Pushinka. Listed as non-breed on her registration, Pushinka had an extraordinary parentage. Her mother, Strelka, was one of the first dogs the Soviets sent into space. The flights of the Soviet dogs had captured the US and the world's imagination, and in a story related to the BBC by her daughter Carolyn, when First Lady Jackie Kennedy ran out of things to say while seated next to Khrushchev at a state dinner in Vienna, she asked about Strelka's puppies, to which the dog had given birth after her famous flight. A few months later, Khrushchev sent Pushinka, the daughter of Strelka, to the White House. According to Carolyn, my father had no idea where the dog came from and couldn't believe my mother had done that. By some reports, Pushinka had to be x-rayed and frisked for Soviet listening devices before being allowed into the White House. Pushinka became a favorite of the Kennedys' children, and also one of the Kennedys' dogs, going on to have a litter of puppies with the Kennedys' Welsh Terrier named Charlie. The puppies were named Butterfly, White Tips, Blackie, and Streaker, and Kennedy reportedly referred to them as Pupnicks. The puppies were given to 4 families in the United States after nearly 5,000 letters arrived at the White House requesting the dogs. About a year after the arrival of Pushinka, the Cuban Missile Crisis, one of the defining events of the Cold War, took place. Historian Martin Sandler argued in his 2013 book, The Letters of John F. Kennedy, that Pushinka and the relationship between Kennedy and Khrushchev helped prevent nuclear war. Animal testing of any kind has always been controversial, and I suppose it's no surprise that a period of extreme competition between nuclear powers that our animal friends would be drawn into the fray. These creatures couldn't defend themselves. They didn't volunteer for missions that had to be, frankly, confusing, painful, terrifying, and for many of them, fatal. But as they always have, man's best friend came with us, even on our most daring missions. And it is no surprise that they also help to bring us together in our darkest hour. I can't help but think that when humankind finally goes out to distant planets, that we won't bring our canine companions with us, and we will settle the stars together. In the 1950s and 60s, the United States and the Soviet Union were locked in a race to see who could be the first to send a man into space. The Cold War was in full swing.
Okay, that's the animals in space one, now standing on Mercury. Goes for a few minutes.
Hi everyone, welcome back to Cody's Lab. So I've got here a jug of about 50 pounds of mercury, and I've brought this down along with 7 other flasks. I've also built a reinforced box which is lined with plastic. I've got some 2x4s and some concrete. Mercury is incredibly heavy. An aquarium wouldn't handle it. So today we're going to see if this liquid metal is dense enough for me to stand on. I didn't want those leaking, did I? So I freshly distilled a bunch of this. So it should be putting all together all my clean mercury. I like how it makes bubbles. See that? You can actually see bubbles in that is actually air bubbles in the mercury. It's almost like soapy water. One of 8. Alright, so here's the last flask. It works really well to pour it from the level of the mercury. That way it doesn't splash. My hands are freezing. I think the mercury's temperature right now is about -1 Celsius or 30 degrees Fahrenheit. Because mercury should be clean. I did distill it once. I mean, it's not triple distilled, but it looks like most of this that's on top is literally just dust. Okay, ready for this? Let's see how much I can get off just by squeegeeing off the top. Oh, that's nice. Now, I would do this barefoot to give people something to comment on. Now, mercury is not as bad as most people think. But I do have an open wound from an ingrown toenail on my other foot, so I think I will put on a pair of boots. Okay, I think we're ready. Let's see what happens. This definitely does not want my foot down in there. Oh, such pressure. Okay, second one. If I can go up. Well, I'm floating on it. It's not easy. Okay, I think oh. It's hard to keep the feet like down at the same level. Okay. I can kind of brace myself against the side of the container, and I am floating on it. There's about 1 inch of mercury underneath my feet. If I pull my feet away from the sides so I don't use that. Okay. It's like trying to balance a broom on your hand. Oh, except I'm the broom. Okay. I fell over. It's actually hard to get back up because I have to put my weight on them to get them to go back down. I actually set this foot all the way down, and let's mark it with a marker what level I'm sinking. So my foot's all the way at the bottom of the container, and then to there. All right? I put my other one in. See, so you can clearly see that I am indeed floating. See, boing, boing. Okay, prove I'm not on my tiptoes. That's actually really hard to stay up like that. Oh. Let's see, watch this. Oh, it's so hard to keep your balance. There's nothing solid to push against. And down I go. Pull down. No, no. Okay, there we go. I'm all the way to the bottom. I let go. Let it go. Alright, Kane. You want to try standing in it? You got smaller feet, so.
Oh dear.
Yeah, I got a pair of boots for you.
These boots are huge.
Yeah, they're a little big for you. That'll actually help. You on the bottom?
Man.
Okay. Gotcha. You floating.
Oh, that is so weird.
Like somebody's squeezing your feet.
Yes.
I let go of you.
Oh gosh, no.
Gotcha.
I float a lot. Like.
Well, you're lighter than me.
Oh yeah, good. Focus on them and see like how high I come up on it.
Okay. Alright, let's step back.
Okay.
So there you have it. When I stood on Mercury, I only sunk into about mid-calf and became incredibly unstable. I think you still could walk on it or remain standing on it, maybe if you could widen your stance a bit and get a lot more practice. The problem was my center of mass is all the way up here, whereas the Mercury was pushing me from way down there. And so, if my center of mass got off from the center of lift, it would just force me over very easily. Usually when you're in water, the water comes like way up to your neck. So, there's no problem there. But the Mercury, of course, is really dense. 13 times denser than water, so you don't sink nearly that far. But the volume of my foot and a little bit of my leg was enough to displace my weight in Mercury, which is, of course, what you need to do in order to float. Now, you don't really need your weight of a liquid in order to float on it, of course. I mean, you could float a battleship in a glass of water if you could put it inside of a dish that is the exact right shape and size for it. What really matters is the pressure. And what I thought was really cool is when I was standing in the Mercury, it felt like my feet were being squeezed because they were. Like my foot is kind of like a void and the Mercury is trying to flow into it, and that creates a lot of pressure, both on the sides and on the bottom. On the sides, the force kind of cancels out, and so it just squeezes tight. But on the bottom, that force is canceled by my body weight pulling down. And if I put more weight on, I'll sink down into the Mercury and get deeper, the pressure will increase, and the force will stabilize, assuming the Mercury is deep enough. Or if I'm too far down, the force on the Mercury will lift me up until the pressure decreases and it stabilizes. I thought that was really cool.
Standing on a foam mattress, such as this, feels a lot like standing on the Mercury. It's got a little bit of a give, but it does support your weight.
If this video is well received, I might try it again with a bunch more Mercury, a big wider dish, and see if I could actually walk on it. But right now, I'm so sore from just carrying that quarter ton of Mercury around. We'll see how it goes. Until then, I'll see you next time.
Not every day that you have a quarter of a ton of Mercury at your disposal. A lot of thermometers there.
You think the cold actually dissolves in the mercury and you separate it by distilling off the mercury. There's a lot of mining mercury poisoning in South America, various places. A friend of mine's got a metal detector and he found a big dot of mercury in the ground. Just like that from a gold mine. Interesting. So he dug it up.
And the last one is water down the Plughole. This is an experiment that was done simultaneously.
In Sydney, Australia, we are at 34 degrees south latitude, which is the opposite side of the world from Huntsville, Alabama. So, which way did the toilets flush? That is the question.
So this is the southern hemisphere version first, and the northern hemisphere won the others.
The Simpsons did a whole episode based on toilets flushing the opposite direction in Australia. Plus, other shows have supposedly demonstrated this effect. So is this a real effect or not?
The application of this principle to draining water in Earth's two hemispheres is just bunk.
If you try it yourself, you'll find inconsistent results. This sink sometimes drains one way and sometimes the other way. In any container of water, there's always going to be some rotation. The water is not perfectly still. And it is this, rather than the hemisphere, that determines which way the water will swirl down the drain. But what if we could eliminate all motion from the water? I have here a 5-foot wide kiddie pool. I actually filled the pool in the anti-clockwise direction to be sure that any clockwise motion we see is not due to the way I filled the pool. I've left this water sitting here for 24 hours. So it seems like I've damped all of the motions from the filling. I really hope this works. Destin, wish me luck. I'm about to pull the plug. 3, 2, 1. And the pool is draining. But you can't see any motion of the water just yet. To help us see where the water is flowing, I'm going to put some food coloring in on the 4 cardinal directions around the pool. You can clearly see that the water is flowing clockwise in this direction, and that makes sense because that's how it should flow in the southern hemisphere due to the Earth's rotation. But you can see what a tiny little effect it is, and what extraordinary lengths I had to go to see this effect. So really, you're not going to see it in a bathtub, and you're not going to see it in a sink or in a toilet, because there are other sources of angular momentum that totally wash out this effect. The Coriolis effect! There you have it! It works! To understand how it works, imagine a pool with one edge touching the South Pole. The pool is stationary relative to Earth, but every day it's actually completing one full revolution. Now you can see the side of the pool furthest from the pole travels much farther every day than the side right next to the pole. So the outer side of the pool is moving fastest towards the east, and as you get closer to the pole, the velocity decreases down to 0. Now, imagine we drain the pool. Water from the far side is moving too fast relative to the drain, and so it gets out ahead, whereas water from near the pole is going too slow, and so it lags behind. So when the water approaches the drain, it swirls clockwise. And this is the reason cyclones swirl clockwise in the southern hemisphere. The higher pressure air rushes into the eye of the storm, and just like in our pool, swirls in the direction dictated by the hemisphere. And that's the truth about toilet swirl.
In Sydney, Australia, we are at 34 degrees south latitude.
Right, that's the southern hemisphere, so you notice that it went down clockwise, and the shorter one is at the northern hemisphere, which was done in Alabama.
Instead of filling the pool with no vorticity at all, I'm going against the way it's supposed to drain. So I'm trying to fill it with a flow going clockwise.
So let's let the water settle for a complete day so that we know that it's perfectly still. Well, I'm not going to reach in and pull a plug out because that would induce some vorticity. I'm going to use this valve that I have connected to the bottom of the pool. Good luck, Derek. Okay, opening the valve in 3, 2, 1. Water should be flowing. Okay, water's been flowing for a couple of minutes and I haven't seen anything yet, so we're going to put some dye in it.
Check it out, it's like a tornado, like right off the bat. We got a counterclockwise rotation. We filled it up clockwise, and now it's going counterclockwise.
We have a kiddie pool in my garage, and the whole earth is rotating, and the water's going counterclockwise because I'm in the northern hemisphere. It's real. This is real. We just proved it because we just eliminated variables. The Coriolis effect is real.
Think about a pool near the North Pole. The Earth is spinning on its axis, so the pool spins around the pole once a day. The whole pool is moving, but the part that's closest to the equator has more momentum, and the part that's closest to the pole has less. Think about these velocities relative to the drain in the middle. When we pull the plug, all the water starts moving towards the middle. The side nearest the equator is going faster, so that water outruns the drain. But the water nearest the pole is going slower, so it falls behind. So when the water approaches the drain, it swirls counterclockwise. This is the reason hurricanes swirl counterclockwise in the northern hemisphere. The center of the hurricane has lower pressure, just like a drain, so the hurricane swirls just like our pool. And that's the truth about toilet swirl.
Instead of filling the pool with no vorticity at all, I'm going against the way it's supposed to drip.
And there we are. So now you know.
They haven't been-
Especially given it's cyclone season. Okay, it's quite late, so I think I'll end the meeting for February, and hopefully we'll see you back here. Sorry, for January, and hopefully we'll see you back here in February.
Thank you.